Hello there, and welcome to the planet's memory, a place where ancient questions are allowed to breathe slowly, and where science drifts like mist across a sleeping ocean. Tonight, we're going to ease into a story buried deeper than fossils and older than the idea of history itself. A story that begins not with a continent, but with a question. What if the ground beneath us once flowed like fire? Not in a metaphorical way, not in poetry or imagination, but in a real physical sense. A time when Earth's entire surface was molten, shifting and glowing and utterly inhospitable to anything resembling life. It's a period few people think about before falling asleep. And yet, it's where every story begins, the one that led to oceans, to continents, to us. Before we go any further, may I ask, where are you listening from tonight? Is there stone beneath your bed? Sand beneath your feet? Maybe concrete, maybe wood. But beneath that, still deeper, is rock. And beneath that, more rock. Layers and layers. Cold now, mostly. But it wasn't always. If you enjoy drifting slowly through questions like this, not rushed, not loud, never dramatic, I'd be honored if you left a like or subscribed. It helps this quiet journey reach others who may be lying awake, searching not for answers, but for wonder. Let's begin where memory begins, even if that memory belongs not to us, but to the Earth itself. There was a time, billions of years ago, when our planet had no name. No forests, no oceans, no continents. Just an ever-shifting, planet-wide ocean of lava. Glowing, writhing, alive in its own way. There were no maps because there was nothing to map. No directions because there was no stillness. Everything was in motion. Everything was heat. There was no north or south, only molten possibility. And in that early silence, long before atmosphere, before oxygen, before even the idea of time as we know it, the Earth was forming its first thoughts. Not thoughts made of language, but of physics, of pressure and release, of heat rising and cooling, of crust forming and breaking again. A kind of planetary breathing. Inhale, eruption. Exhale, collapse. It is hard to imagine, but the minerals beneath your feet remember. Trapped within certain ancient crystals, tiny relics known as zircons, are isotopes that tell us stories of these first fiery moments. Stories hidden in ratios, in atomic scars, in radioactive trails left behind like footprints in lava. These are the oldest solids on Earth. Some are over 4.3 billion years old, and they whisper that even amid oceans of fire, the Earth was already learning to cool. But cooling takes time. More time than we can comfortably hold in our minds. Hundreds of millions of years passed, entire epochs of heat, before the first stable crust emerged. And even then, it wasn't the crust we know. It wasn't land exactly. It was more like a raft. A thin, trembling surface floating atop a restless interior, constantly cracking, reforming, sinking again. So what does it mean that the Earth began in fire? Perhaps it tells us something about transformation, about patience, about the long, slow arc of change. That even the most violent beginnings can cool given time. That memory, real memory, is not always gentle. Sometimes it is seared into stone. Imagine walking outside right now. You take a step, then another. The sidewalk is cool. The ground is quiet. But deep beneath you, there is still fire. The mantle still churns. The core still burns. The past is not gone. It's just layered, buried, dreaming. And what else might be sleeping under there? If our planet began in lava, then what was lost in the fire? What secrets were erased before they could fossilize? Before there were fossils at all? Could there have been cycles of crust that formed and vanished before the ones we now study? Could something, anything, have emerged only to be swallowed again by the heat? We'll never know for sure. But some scientists wonder if certain isotope trails suggest there were older crusts now gone. An ancient Earth before the ancient Earth. The idea is called Hadean recycling, the possibility that the very first rocks were born, destroyed, and born again before the crust we call primordial even existed. And that opens a quiet door. Because if history can erase itself so completely, what else might have existed, only to vanish without a trace? Not because it was unimportant, but because lava does not keep memories the way sediment does. Fire does not archive, consumes. Still, even consumption leaves behind shadows. Ghosts in the geochemistry, questions in the layers. Maybe, maybe not. But maybe, we walk on what feels like permanence. Mountains, continents, bedrock. But the earth remembers a time when none of this stood still. When there was no land, only lava. And even now, it remembers. Every tectonic tremor, every distant volcano, every whisper of warmth deep in the mantle, is part of that memory rising again. And yet, if this much can be lost, what else might we have forgotten? There is a time beyond memory. Not the kind we misplace or blur with age, but something more absolute. A time when forgetting wasn't even possible, because nothing yet existed to hold on to anything at all. Before fossils, before rivers, before even the gentlest trace of sediment. There was only molten motion, a landscape not yet solid, a world without edges, without archives, without anything you could call a beginning. Imagine a planet with no soil, no sand, no shorelines. Only the endless churn of magma, glowing beneath a heavy sky, or perhaps no sky at all, only atmosphere in flux, thick with vapor and violence, and Earth still making up its mind about what it would become. We sometimes speak of the beginning of time, but that's not this. This is the beginning of texture, of form, of boundary, and even then it was temporary. Geologists call this era the Hadean, named after the underworld. Not because it was evil or doomed, but because it was unknowable, hidden. A time that resists reconstruction. Most of its rocks have been melted, eroded, or subducted back into the Earth's interior, swallowed by the very crust they helped form. It's as if the planet itself has overwritten its earliest memories, layer by layer, lava flow by lava flow. And yet, small clues remain. Microscopic zircon crystals, barely visible to the eye, have been found embedded in younger rocks in parts of Australia. They are the oldest known materials on Earth, dating back over 4.3 billion years. Inside them, isotope traces suggest something remarkable. That even during this fiery chaos, parts of the Earth cooled just enough to host liquid water, perhaps even brief, unstable protocrusts. Not land exactly, not continents, but maybe the first pause, the first whisper of stillness. Stillness is what allows memory to begin. Sediment only settles when motion slows. And yet, in the Hadean, there was no true stillness, only fluctuation. The Earth's surface behaved like a liquid memory, refusing to hold its shape. It bubbled, cracked, shifted, and started again. If stones are how Earth remembers, then this was the time before remembering was possible. A time when the planet could only feel, not yet reflect. When heat was constant, and silence, true silence, could not yet form. There were no fossils, no shells, no carbon signatures from life. But maybe something like intention was already forming in the patterns of heat and pressure. Maybe the dance of molten rock beneath cooling crust was not random, but rhythmic. Maybe entropy itself, the universal pull toward disorder, was writing something down, not in words but in consequence. We imagine Earth as a place, but in these early moments it was more like a process of becoming. And in that becoming there was loss. Not tragic loss, just quiet dissolution. Forms that rose and fell too quickly to ever be seen. Landscapes erased by the very forces that birthed them. Shorelines that evaporated. Valleys that folded inward. An entire terrain of impermanence. It's humbling, isn't it? To know that the rock you might hold in your hand today comes from a lineage of stone that no longer exists. That everything solid is built upon the ashes of things that melted before it could be remembered. We don't walk on the Earth's original surface. That surface is gone. What we stand on is its descendant. And even this will change. This is the paradox of permanence. That even stone has a lifespan. And so we imagine the molten plains, vast and luminous, without edges, without names. No wind, no soil, no time as we know it. Only cycles of heat, convection currents rising and sinking, pressure building beneath unstable crust. Subduction zones forming before they had continents to swallow. A world in motion, not yet alive, but already dreaming of the conditions life would require. Could it be that the Earth was already writing a kind of prelude? That even in this forgotten era, patterns were forming that would later define biology, chemistry, memory? Could the randomness of lava flows hold echoes of the intelligence that would one day study them? Maybe, maybe not, but maybe. And if we could travel back, not just through layers of rock, but through layers of forgetting, what might we feel standing barefoot on those first cooling plains? Would the heat hum beneath our soles? Would we recognize anything as familiar? Or would the whole world feel like a memory still forming? We'll never know exactly what those early surfaces looked like. They left no photographs, no bones, no stories carved in sandstone. But in their absence, they left something just as powerful: the invitation to wonder. And that may be the beginning of all memory. Even now, every stone that forms is shaped by what came before it. The atoms remember even if we can't. Heat leaves residue. Pressure leaves structure. Decay leaves space. The Earth has always remembered through transformation. But before that, there was only the fire. And if memory begins only after motion slows, what happens when the ground finally starts to hold still? Not all at once. Not with certainty, but with hesitation. The Earth began to cool. Not evenly, not quietly, but in fragments, a scattered pause in the long breath of molten flow. For the first time, something resisted the fire. Something chose to remain. And in that fragile stillness, the first crust was born. It was not like the continents we know today. There were no shorelines, no plateaus, no firm divisions between land and sea. There was no sea at all, only vapor above and magma below. But across this glowing, restless surface, patches began to form. Islands of solidity, not permanent, not stable, but solid enough to interrupt the endless motion. Solid enough to leave behind the first outlines of form. The Earth was growing a skin, not one it planned, not one it designed, but one that emerged from temperature shifts, from the quiet war between heat and time. Where molten rock cooled just long enough, where convection currents thinned just slightly, where the mantle exhaled a little slower, there crust began to crystallize. We call this process differentiation, the slow separation of heavier and lighter materials, driven by heat, gravity, and the internal churn of a still-forming planet. Iron sank, silicates floated, and somewhere between the two, the crust found space to form. Cracked, of course. It always cracked. No crust lasted long in those early ages. The pressure below was too immense, the surface too thin, the planet too alive. Each new layer formed like ice on boiling water. Brief, uncertain, always on the edge of collapse. But with each cycle, something was remembered. And each memory helped the next one last a little longer. You might picture these first crustal rafts like broken puzzle pieces floating on a lava ocean. Unanchored, adrift, sometimes merging, often sinking, occasionally surviving long enough to become part of something else. They didn't build a continent. They didn't even build a landmass. But they changed the story. Because once you have something solid, you have the beginning of resistance. And once you have resistance, you have structure. And once you have structure, the Earth can begin to tell time, not in hours or years, but in layers, in pressure lines, in chemical signatures, in the scars of heat endured. Beneath the cool stillness of today's rocks, we find whispers of the skin's birth. Ancient zircons, again, those tiny time capsules, but also geochemical hints in some of the oldest crustal remnants, found in places like the Jack Hills of Western Australia and the Acasta gneiss in Canada. These are not fossils of life. They are fossils of cooling, fossils of the Earth learning to hold its shape. And yet, even now, the crust is not truly solid. Not the way we imagine. It floats. It shifts. It bends and breaks and reforms. The plates we walk on drift like slow ships on a hidden sea. The ground we trust to stay still is, in truth, always moving, just too slowly for us to feel. But compared to that early world, it is calm. It is memory made stone. The first crusts were likely mafic, dark, dense, rich in magnesium and iron. Basaltic, like the floors of our modern oceans. Lighter granitic crust, the kind that forms continents, came later, perhaps seeded by volcanic islands, perhaps formed through countless cycles of melting and rising, erosion and burial. Nothing happened all at once, but everything happened because of what came before. So when we speak of the birth of the Earth's skin, we're not describing a moment. We're describing a possibility that kept trying to become real, and failing and trying again. And in those failures, something lasting began to emerge. It is strange to think that the ground beneath us was once an experiment. That land itself had to be earned through time and heat and entropy. That permanence is always provisional. But maybe that's what makes it sacred. And maybe that's why we remember. Not because the first crust survived, but because the attempt left traces. Because even destruction can leave behind direction. Because even what fails can teach the earth how to try again. We are used to thinking of skin as protection, a boundary between inside and out. But the earth's skin was different. It was not a shield. It was an opening, a threshold through which memory could begin to form, a surface where water could someday gather, where atmosphere could touch ground, where chemistry could slow down long enough to notice itself. The crust is where geology first becomes storytelling. And just beneath it, always waiting, is fire. Because cooling is not an ending, only a lull. A pause. A fragile breath in the long conversation between heat and time. The mantle still turns. The plates still shift. The skin still cracks. But now it does so more slowly. Now it remembers. And the moment the earth began to hold its shape, it also began to shape what came next. Because once land exists, it can be broken. And once something can break, it can begin to erode. But before erosion, before rivers had a path to follow or wind had a mountain to wear down, there were brief moments of stillness. Small, scattered fragments of crust, cooled just enough to float atop the fire. They didn't last. Most of them were lost. But they mattered not because they survived, but because they tried to. Picture a glowing, restless sea. An entire planet still wrapped in its own heat, its surface more liquid than solid, its air thick with vaporized rock. In this chaos, there were places that dared to cool. Not fully, not forever, but long enough to hold a shape, long enough to float. They were not continents, not even islands in the way we think of them now. They were crustal rafts, fractured bits of early lithosphere, chemically distinct from the lava below, buoyant enough to resist sinking for a while. We sometimes call them protocontinents, not because they grew into today's landmasses directly, but because they hinted at what was possible. They were experiments in stability, petri dishes for geology, and maybe the Earth's first attempts at memory. To float at all in such a place, a rock had to be light, less dense than the molten world it sat upon. And that required differentiation, the slow sorting of Earth's materials by weight, by chemistry, by temperature. Lighter silicates rising, heavier metals sinking, and in some rare combinations, a patch of crust would emerge that didn't immediately melt, that didn't immediately fall. It held. And in that brief stillness, something strange began to happen. Inside these rafts, minerals formed differently. They crystallized more slowly. They recorded more detail. Their isotopic ratios changed, telling subtle stories of pressure and time. In tiny grains of zircon, and in the oldest tonalite and trondhjemite rocks, scientists find echoes of these first still places. Echoes, not maps. Suggestions, not evidence. But enough to wonder. Enough to believe that stillness, even momentary, can leave a mark. Some of these fragments may still exist, buried deep within modern cratons, the ancient cores of today's continents. They are like geological time capsules, older than any mountain, older than any ocean, folded and compressed beneath layers of newer crust. To find them is to glimpse a world before erosion, before biology, before even plate tectonics as we now understand it. A world where the most radical act was to remain in place, because everything else was moving, everything else was flow. These islands of stillness didn't stand against the chaos. They floated within it. They didn't resist the heat. They worked with it. Their stability was fragile, conditional, always under threat. But they persisted, not always, not often, but just enough. And from their cooling surfaces, new possibilities emerged. Maybe the first weather. Maybe the first rain, briefly pooling on rock that didn't instantly steam it away. Maybe the early hints of a water cycle, of atmosphere touching ground, of reactions happening more slowly, long before life, long before anything could record what was happening. The conditions for recording began, and that matters, because if the planet had never learned to hold still, even for a moment, none of what followed could have taken root. Life requires pauses, requires patterns that persist, requires a stage upon which complexity can repeat itself long enough to evolve. Stillness is not the opposite of chaos. It's the pause that gives chaos meaning. And when we look into the oldest rocks, we don't just see mineral composition or isotope decay. We see evidence of rest, of patience, of geology beginning to wonder what it might become. Not because it planned to, not because it knew, but because even a molten planet can learn to slow down. And from these early rafts, these proto-islands in a sea of fire, something else began to stir. Something quiet, something soft. Because once a rock floats, it can be weathered. And once it is weathered, it can become sediment. And sediment, for the first time, can begin to remember. But before memory settled, before water carved anything, there was a time when the skies held no clouds. No rain fell, no rivers ran. Only fire moved and only heat spoke. This was a world where the very concept of weather, the gentle chaos of clouds and currents, did not yet exist. The air was not breathable, not even truly air. It was a storm of gases and vaporized rock, churning in thick veils above an earth still glowing from its own creation. We often forget that weather is a gift of cooling. That wind, rain, and snow only happen when temperatures allow water to shift between forms. But when the world was young, far too young to soften, heat was the only motion. Fire was the only rhythm. And in this rhythm, there were no seasons, only radiant storms. Imagine standing, if you could, in a moment like that, the sky not dark, but glowing. Not from sun or stars, but from the ground itself. Lava pouring across a landscape of molten ridges, evaporating anything that dared to fall upon it. Lightning not from thunderclouds, but from friction in ash. Explosions not shaped by air pressure, but by gas bubbles escaping molten chambers. It was loud, perhaps, in physical terms, but emotionally, cosmically, it was silent, because nothing was listening, nothing was waiting, nothing yet existed to wonder what came next. And so, in a way, it was the loneliest weather the earth has ever known. There were no trees to burn, no oceans to boil, no skies to clear, only the cycle of fire folding into fire, again and again. This was a time of radiative balance, the planet releasing the heat of its own formation through the only method it had: light. Infrared, searing, constant. The very surface of the earth was too hot to hold water, too unstable to form clouds. And so, the idea of weather as we know it, the dance between atmosphere and ocean, between heat and pressure, had not yet begun. But there was still motion. Volcanoes erupted, endlessly, like breath. Cracks opened, lava surged, planetary winds, not gentle breezes, but fast-moving flows of hot gas, swept across the sky without blue. In the absence of water, the winds carried dust. Not sediment, not soil, just the fragmented breath of rock. Silica, ash, vaporized minerals, all suspended in the thick air. Could you call this a storm? Maybe. But it was a storm without a cycle, without relief, without contrast. The difference between sky and ground blurred, both glowing with similar heat. No shadows, no shelter, only radiance, unfiltered, uninterrupted. This was Earth's earliest weather. Not weather we could survive, not weather we could watch, but weather just the same, raw, unbalanced, and sacred in its own strange consistency. We learn from planetary scientists that during this phase, often called the magma ocean stage, the Earth's surface could have reached temperatures well over 1,600 degrees Celsius. Oceans of lava hundreds of kilometers thick churned beneath a volatile atmosphere of carbon dioxide, nitrogen, sulfur, and steam, and until the crust cooled enough to trap that heat, to let water condense, the fire reigned. And so we ask, what is weather without water? Can a planet have climate before it has rain? Does fire count as a season when it never truly ends? Maybe weather is not defined by water at all, but by motion. And this world, though unimaginable to us now, was in constant motion, a place of transition, of radiant entropy, and somehow that endless radiance laid the foundation for everything that followed. Because as fire thinned the atmosphere, it also reshaped the crust. As lava surged across the surface, it built the rock formations that would later become mountains. As magma cooled, reluctantly, across the edges of stillness, it prepared the world for weather that could change. And eventually, it did. Water, perhaps arriving in part from ancient asteroid impacts, or rising up from deep interior reactions, began to accumulate. Slowly, tentatively, first in vapor, then in brief droplets, then in sheets. And one day rain truly fell, not into oceans but onto fire. And that was the first sound. Not the silence of eruption, not the breath of ash, but the quiet, sacred hiss of water meeting lava. What must that moment have felt like? Not to us, we were not yet even dreams, but to the planet itself. The meeting of opposites. The first partnership between solid and liquid. The first tension between cooling and erosion. Between patience and loss. Fire was never banished. It remains always just beneath the crust. But it was no longer alone. The skies had changed. And in their change, the story changed too. But before all that, there was only fire. And when fire was the only weather, the earth held no memories, only heat. And yet, even heat fades. And when it does, the planet begins to breathe differently. Because once rain falls, it can begin to carve. And once water touches stone, something begins to echo. But before rivers had voices, before valleys carried rain to ocean, it was the volcano that first spoke for the earth. Long before wind and waves found their rhythm, the planet exhaled through fire. Its language was eruption, its breath volcanic. These were not the volcanoes we know today. There were no picturesque cones against a blue sky, no snow-capped peaks trembling with quiet power. There was no sky to speak of, not yet, not fully. Only haze, vapor, light filtered through clouds of ash and carbon, thick with unspoken chemistry. The volcanoes of Earth's youth were broader, deeper, more continuous. Not isolated peaks, but vast fractures, molten arteries that ran through the crust like wounds too fresh to scar. They erupted not in moments, but in ages. Basalt floods stretched across thousands of kilometers, darkening the surface with every breath. And yet, these were not acts of destruction alone. They were acts of creation. Every eruption built something, not just land but possibility. With each plume of gas and molten stone, the planet reshaped its own body. Lava fanned out across the early crust, cooling into new layers. Ash settled and layered into protosoil. Gases poured into the atmosphere, thickening the air, changing its chemistry, one eruption at a time. It was messy, it was loud, but it was language. Because if the earth had thoughts before it had life, they came through volcanoes. Think of this. When molten rock rises through the crust and bursts into air, it brings with it secrets. Elements forged in the mantle. Heat stored since formation. Isotopes waiting to decay. Each eruption is not just a release. It's a revelation. And in the Hadean and Archean eons, Earth revealed itself constantly. In these ancient volcanic breaths, we find the building blocks of what came next. Carbon dioxide, essential to the greenhouse effect that kept early Earth warm. Sulfur, which would someday shape cloud cover. Water vapor, perhaps expelled from deep within the mantle. seeding the skies with the first hints of rain. But volcanoes didn't just give. They also took. Each eruption buried what came before. Cooled crust was remelted. Any trace of early sediment was swept away. Even the smallest experiment in stillness in memory erased by the next surge of heat. A fossil could not survive here. Nothing delicate could last. Volcanism was the editor of Earth's early history, redacting entire chapters before they could be read. So we're left wondering, what did they shape? And what did they erase? Did the very first crustal rafts rise from volcanic rock, only to be consumed again by it? Did rainfall fall upon volcanic plains, only to evaporate in seconds? Did early mineral layers, strange and unstable, once form only to be swallowed by magma and replaced? We do not know. But we do know that volcanoes were sculptors. Patient, relentless, unforgiving. They built the surface in layers, each one a breath hardened into stone. Over time, those layers became provinces, large igneous provinces as we now call them, sprawling basaltic plateaus that testify to the scale of ancient eruptions. We also find them in greenstone belts, complex zones of ancient volcanic and sedimentary rock, crushed and folded over billions of years. In them are hints of how life might have eventually emerged near hydrothermal vents, in the warmth and chemistry volcanoes provided. Because for all their violence, volcanoes are also cradles. They bring up what is buried. They mix. They spread. They stir the pot of planetary chemistry. And in doing so, they create the conditions for complexity, for reactions that might otherwise never happen in stillness. Even today, volcanoes breathe life into ecosystems, providing heat, minerals, and new land. But back then, they were everything. The first breath, the first builder, the first eraser. The Earth's voice, raw and constant. And in that voice was rhythm. Not randomness, not chaos, but a kind of molten heartbeat pulsing through geologic time. Eruption, flow, cooling, eruption again. A tempo not measured in seconds, but in eons. And in between those breaths, in the rare, brief pauses, something else was waiting. Because once volcanoes rest, even for a moment, ash begins to settle. And when ash settles, it can become layer. And when layer forms, it can be pressed into story. Not all stories begin with words. Some begin with dust. Not the kind you sweep from shelves or let drift through sunlit air, but a finer dust. Volcanic ash, suspended in ancient skies, floating slowly down through the heat. These particles, weightless in the moment, would one day become the first pages of the Earth's memory. It is strange to imagine that something so soft, so temporary, might outlast mountains. That ash, born in violence, scattered by wind, forgotten the moment it falls, could become stone. And that stone could remember. But that is exactly what happened. In the rare, quiet spaces between eruptions, when volcanoes paused to breathe in rather than out, ash would settle. Not all at once, not evenly. It fell in veils, layer by layer, onto crust just cool enough to hold it. It mixed with time, compressed with weight. And slowly, over thousands of years, it became tough. A type of rock made from volcanic ash, cemented into place by pressure, by chemistry, by patience. These were some of the first layered rocks. And in them, the planet began to record not just its composition, but its rhythm. Every layer told a story of eruption, where it came from, how hot it burned, what gases filled the air when it fell. And between those layers, if the ash fell on crust exposed to air or water, there could even be tiny gaps, moments where rain touched stone, or where minerals leached through with the slow hand of early weather. No life had yet come to read these layers, but they were being written anyway. This was memory before meaning, pattern before perception. Ash is light, fragile, easily carried away. But once buried, once trapped beneath more ash or more lava, it begins to change. Minerals rearrange. Heat alters texture. What was once dust becomes stone. And that stone, if lucky, survives. Some of the oldest sedimentary rocks on Earth, places like the Barberton Greenstone Belt in South Africa, or the Pilbara Craton in Australia, contain hints of ancient ash, layered between lava flows. Their structures speak in fine bands, like tree rings or tidal lines, but with no witness to see them form. Only the earth quietly keeping track. And though we may never know exactly what those eruptions erased, the ash they left behind hints at what once was. What gases filled the sky. What minerals existed in the crust. What temperatures shaped the air. Even without fossils, ash preserves context. It captures the mood of the earth at the time of its fall. Could it be that, in this way, the planet found a way to remember its own silence? To trap not just heat and pressure but pause? Because ash only settles when the wind slows, when eruption ends, when motion quiets long enough for gravity to take over. And in that descent, soft, slow, steady, something sacred happens. The temporary becomes permanent. The fleeting becomes form. This is the paradox of ash. It disappears the moment it arrives. And yet, when buried, it may last for billions of years. It holds no bones, no leaves, no names, but it holds sequence. One layer, then another, and between those layers, time gathers like breath. We call this stratigraphy the science of layers, of reading Earth's history like a book made of pressure. But even before there were books, before there were pages, there were ashes. Ash is the first whisper of narrative. A memory not made of story, but of settling. Could the Earth have known that it was beginning to remember itself? Probably not. But maybe the rhythm of falling ash became something more than chance. Maybe, over time, it gave structure to memory. A skeleton for geology. A sequence for what came next. And maybe, in the dust of forgotten volcanoes, are the pages of a world that no longer exists. Because once ash becomes stone, it can be read. And once something can be read, it can be misread. And in the gaps between what we know and what we imagine, there is room for wonder. There is room for echoes. There is room for the Earth's next breath, one that comes not from above, but from below, especially in the deep places, in the silence beneath our feet, in the slow, forgotten chambers of stone where pressure gathers like thought. Because not all stories rise to the surface. Some remain buried, pressed into the earth like secrets, and some become mountains. But before there were peaks to look up to, there were hollows, vast, molten reservoirs buried beneath the skin of the earth, chambers of fire swelling in the dark. These were the cradles of later summits, not sharp, not tall, but full of molten memory, of minerals waiting to cool, of pressure learning to shape form. The roots of mountains began not as stone, but as magma. Deep below they pulsed, slowly, heavily, silently, pools of molten rock rising through fractures in the crust, collecting in pockets, waiting for change. Sometimes they erupted, sometimes they didn't, sometimes they simply cooled, solidifying into plutons, the deep hearts of future peaks. We see them now only in cross-section, in places where erosion has stripped the skin away, revealing granite spires and batholiths like frozen thunder. But long before they stood exposed, they were hidden, and the earth pulsed around them. This was the beginning of orogeny mountain building. Not sudden, not violent in the way we imagine, but slow, inexorable, driven by plate tectonics, by the gentle collision of continental crusts. When plates met, pressure built. When pressure built, the crust folded. And beneath the folds, magma chambers swelled. Not all magma reached the surface. Much of it stayed below, cooling over eons, forming crystalline cores. These would become the seeds of mountains. And mountains, in time, would become memory. Because mountains remember differently. Where sediment tells a story in layers, mountains tell a story in force. In uplift, in fracture, in the deep folding of ancient stone. Their roots stretch far beneath what the eye can see, sometimes deeper than the mountain is tall. A kind of geological mirror. What rises up is only half the truth. And down there, in the dark, the earth still speaks. Seismologists, scientists who listen to vibrations, record echoes that move through these deep roots. Earthquakes send waves that bounce and bend and warp beneath mountain ranges, revealing the shape of chambers long cooled. A whisper of heat here, A pause in density there. Subtle clues buried deep. These are the echoes beneath our mountains. Not sound in the usual sense, but movement, tension, time compressed into pressure. What do they say? They speak of old collisions, of continental plates that met, merged and stayed, of crust so thick it bent instead of breaking, of magma that never erupted, but held its breath and turned to granite. They speak of ages when mountains were not yet visible, but already growing. And in some of those echoes, we hear something even older. Fragments of cratons, the ancient cores of continents, sometimes lie beneath modern ranges. These are remnants from Earth's earliest skin, compressed and buried, but still intact. They whisper of a time before mountain chains, before erosion, before plate tectonics found its full rhythm. We dig deep and find rocks older than mountains, rocks that remember the world not just as it looked, but as it felt. Geology in this way becomes emotional, not dramatic, never rushed, but full of presence. You feel it when you walk along a mountain trail, not just from the height, but from the stillness, from the deep sense that these shapes were not carved by surface alone, but by forces far beneath, forces that moved slowly enough to outlive memory. And perhaps that is what mountains are, memory held upright, not static, not eternal, but enduring. Even now they change, they crumble, they rise. They are worn by weather and reshaped by time. But deep beneath, their roots still pulse. The mantle still turns. New chambers still form. The earth has not stopped building, only slowed. And so we ask, if these echoes still rise through the crust, what else might they be carrying? Could traces of the first eruptions still linger in the core of a modern mountain? Could isotope trails, trapped in ancient granite, still record the temperature of a magma ocean long gone? Could the silence beneath our tallest peaks be telling us something we forgot to ask? Maybe, because the higher a mountain reaches, the deeper its root must go. And the deeper we go, the more ancient the echo. But what if, buried deeper than any tectonic root, hidden far beneath the reach of erosion or memory, there was something else? Not just stone, not just magma, but something made, something deliberate, something left behind. It's a question too strange for textbooks, and yet too persistent to ignore. If a civilization lived in the lava era, what would remain? Not myths, not campfire stories, not metaphor, but geology. Could there be technofossils older than we assume? Not the bronze of old empires, but something far more ancient, something forged and forgotten. We're not asking this as science fiction. We're asking it as planetary archaeology. Because every civilization, including ours, leaves a residue, an imprint in the geological record. From concrete to plastics, from radioisotopes to metal alloys that do not occur naturally. Even if we vanish tomorrow, our trace would persist. Deep beneath future sediment, there would be strange seams in the rock, synthetic elements fused into layers of anthropogenic stone. These traces are what we call technofossils, the fossilized remains not of biology but of technology. And here's the thought that trembles quietly in the background. What if we're not the first? It seems impossible. The earth was molten, the crust was unstable, the atmosphere poisonous, water was scarce. Life, as far as we know, hadn't even begun. But we don't know everything. We only know what we can prove. And proving absence is harder than proving presence. So we ask gently, not to disturb but to imagine. If something arose before us, what would it leave? Would it be swept away in fire, erased by the same lava flows that destroyed the first crusts? Would its structures sink back into the mantle? Would any material, any alloy, any form of data survive the crushing pressure and impossible heat? Or would some fragment remain? Maybe not as a tower, not as a tablet or tool, but as a chemical anomaly. A seam of unusual metal ratios in the deep crust. A pocket of layered compounds that do not belong. A magnetic signature too stable, too patterned to be random. We are trained to dismiss such things as coincidence, as contamination, as noise. But maybe some of that noise is echo. After all, we already find things we don't fully understand. Traces of graphite in 3.7-billion-year-old rocks, possibly of biological origin. Iron formations laid down before oxygen should have existed. Zircon crystals that hint at water cycles older than our models suggest. None of these things prove anything, but they invite us to soften certainty. Because technofossils, if they exist from a time before known life, would not look like anything we expect. They wouldn't resemble us. Their materials might not match our inventions. Their logic might not match our own. But geology doesn't care about logic. It records whatever touches it. Slowly, unfeelingly, without bias. So perhaps we should ask a different question. What kind of evidence could survive billions of years of planetary churn? Maybe not data, not in the form of symbols or language, but structure, order, repetition, mineral alignments that suggest machining, isotopic concentrations that defy natural process, crystalline arrangements with unnatural purity. To us, these might look like quirks in the rock. To future geologists, they might look like coincidence. But what if, just what if, they are not? There's a quiet humility in this question. Not paranoia, not fantasy, just wonder. Because if such a civilization ever existed, even briefly, even fragmentarily, we might never know. Its world would have been different. Its surface temporary. The sky thick with haze. It may not have lasted long. But neither did ours in the scale of deep time. Civilizations are not measured in calendar years, but in the thickness of layers they leave behind. And if one left no layer, would it still have been real? Maybe. Maybe it lived and vanished before the crust stabilized. Maybe it seeded the chemistry we later built upon. Maybe it rose from geothermal pockets in the shadows of ancient volcanoes, only to be swallowed again by the molten tides. Or maybe we are the first, and the only, and that too is worth sitting with, because it means we are the first to leave a technofossil layer, the first to inscribe circuitry into stone, the first to alter the atmosphere not by eruption, but by industry, the first to change the climate not through collision, but through choice. We are making fossils not of ourselves but of our effects, and someday, long after we are gone, those effects will speak. Even if no one is left to listen, even if they are buried beneath fire again, even if they are mistaken for something else. Because once a world has been touched by mind, it carries that imprint forever, not in memory, but in matter. And the earth is very good at holding matter, even if it forgets everything else. Because once a world has been touched by mind, it carries that imprint forever, not in memory, but in matter. And yet, matter can melt. And when it does, it forgets. There's a softness to erosion, a kind of patience. Wind rounds the edge of a stone. Water wears the face of a cliff. Glaciers carve valleys with the grace of time unfolding. Erosion takes millennia. It removes, but it leaves behind outlines, clues, sediments, broken remnants that still remember what they once were. But lava is not patient. Lava does not smooth. Lava consumes. It floods. It buries. It burns everything back to the beginning. And so we come to one of the Earth's deepest silences, a kind of planetary amnesia. Not a forgetting by accident, but a forgetting by heat. A deliberate erasure written in fire. We often speak of fossils as memory. Bones hardened into stone, footprints preserved in ash, shells embedded in ancient mud. But for a fossil to form, the conditions must be perfect. The body must escape decay, be buried quickly, survive pressure, evade disturbance. And above all, it must not burn. Because lava does not fossilize. It leaves no bones, no books, no ruins. When molten rock sweeps over a landscape, it does more than transform. It resets. It wipes the slate clean chemically, geologically, historically. A pyroclastic flow can obliterate a forest in seconds. A lava field can seal a valley for millions of years. We call these events extinction by eruption, not because life disappears instantly, but because the record of its existence is lost. Forever. So we ask, what truths might have melted beneath lava's tide? Not just bones. Not just buildings. but entire chapters of planetary history. Terrains, climates, living systems, erased so completely they left no trace behind. Perhaps even civilizations, if such things ever dared to rise too soon. And the terrifying beauty of lava is that it leaves behind no absence. The surface it creates is smooth, coherent, new. There is no visible hole where memory once lived. Only basalt, only silence. This is the danger of planetary amnesia. Not that it forgets, but that it forgets perfectly. Volcanic provinces such as the Deccan Traps in India or the Siberian Traps in Russia are made of layer upon layer of ancient lava, stacked hundreds of meters thick, spread over millions of square kilometers. These were not brief eruptions. They were epochs of fire, and whatever lay beneath them is gone. Geologists know this. They call these sequences unconformities, gaps in the geologic record where something once existed, but no longer can be studied. In most cases, erosion caused the missing data, but in others, it's lava. Fire with no mercy. Fire with no archive. So what happens to knowledge when the archive is erased? We try to rebuild it. We read the chemistry of the lava itself, searching for trace elements, for gases it absorbed, for minerals it fused, for clues it accidentally preserved. Occasionally, there are inclusions, fragments of the crust the lava swallowed before hardening. These are called xenoliths, and they are like forgotten voices trapped in a new chorus. They do not speak loudly, but they speak. Still, most of what lava touches disappears. Not by breaking, not by crumbling, but by ceasing to exist. Could it be that entire ecosystems have vanished this way? Not slowly like the dinosaurs, but all at once. A whole biome swallowed in hours, reduced to silence in a single tide of heat? Could it be that life tried, and lava replied? Maybe, because not all extinction leaves behind bones. Some leaves behind glass. Obsidian, volcanic glass, is one of lava's only delicate gifts. Formed when molten rock cools too quickly to crystallize, it is sharp, beautiful, and fragile. It holds no memory itself. But it reminds us that even in destruction, there is potential for art, for reflection. Perhaps lava is not a villain in the story. Perhaps it is the editor, the redactor, the necessary force that deletes so that something new can begin. But still, there is loss. Because while erosion reveals, carving out the past one layer at a time, lava conceals, coats, it buries. And beneath its hardened fields may lie stories we will never read. So we must ask, what is history, if most of it is missing? What does it mean to live on a planet that forgets as much as it remembers? Maybe that's why we dig, why we study, why we wonder, because in every gap, in every silence beneath the basalt, is the ghost of a possibility. And that ghost asks quietly, what did the earth know once that it no longer remembers? Maybe it knew a different sky. Maybe it knew a warmth that wasn't fire. Maybe it knew names we will never speak. And maybe, just maybe, if forgetting can happen so completely, we too might one day be erased without trace. Not because we were small, but because the fire was large. Because entropy is not cruel, it is only indifferent. Because memory is fragile, and the earth is always rewriting. And yet, there was a moment, a long, unspoken moment, when the rewriting slowed, when the last great sheets of lava cooled not into chaos, but into calm, when fire faded from the surface and did not return. And in that stillness, something unfamiliar filled the air. Silence. Not the silence of space, cold and absent, but a terrestrial silence. Heavy, thick, a quiet made of stone. Imagine the world then, not yet alive, but no longer burning. The skies still thick with carbon and haze, the oceans perhaps still forming in the deep basins carved by fire, the continents barely outlined, just fractured crusts floating over the warmth below. The storms had passed, the eruptions had eased, and all across the surface of the earth, there was nothing but stillness. Stillness without sound, without voice, without witness. We rarely speak of this chapter, not because it's unimportant, but because it's so hard to see. Lava leaves texture. Life leaves fossils. But what does absence leave? What shape does waiting take? For possibly hundreds of millions of years, the Earth existed in this suspended pause, a place between events. The crust had formed. The worst of the bombardment had ended. The fire had moved inward, sealed beneath stone. And biology had not yet begun. This was a world in transition, a lull in the symphony, a quiet breath before the first note. We sometimes call this the prebiotic Earth, a planet without life but with the potential for it. The ingredients were there: water, energy, organic molecules perhaps delivered by asteroids or formed in deep-sea vents. But the recipe had not yet begun. The kitchen was ready, but no one had lit the flame. And so the planet waited. Was it beautiful? Perhaps not in any way we would recognize. There were no flowers, no forests, no coral reefs to stir the imagination. Only rock and water, only clouds and heat. But there must have been shapes. Coastlines newly formed, valleys unscarred by rivers, mountains unburdened by time, and beneath it all, stillness. We speak of silence as nothingness, but this was a full silence, a silence heavy with potential, a silence on the edge of becoming. There is something profound in that, because we tend to believe that life is the default, that given the right ingredients it must appear, and perhaps it will. But even on Earth it did not appear immediately. There was a long patience first, a great quiet between geology and biology, and in that quiet, the stone had its moment, not as background but as subject. The rocks of this age, now hidden, now altered, were the first stable surfaces the planet had ever known. They held the first raindrops. They absorbed the first winds. They watched the first chemistry unfold in tidopools, in fractures, in deep submerged places. They were the Earth's original audience. Long before cells, before instincts, before memory, the rocks listened, or maybe not, but they were there. And so we look back not to find evidence of life, but to honor the time before it. A time we will never truly recover. A time when no one watched the sunrise, and yet the sun still rose. No photos, no fossils, just stone. And the faint chemical fingerprints of reactions beginning to stir, amino acids forming, perhaps, from heat and lightning. Carbon molecules drifting through shallow seas. The planet humming quietly to itself, not yet aware of what it was about to become. This is where philosophy meets geology. Because what is a world without life? Is it empty? Or is it simply resting? Is it unfinished? Or just listening? The silence between cooling and life is not nothing. It is a kind of cosmic inhale, the breath before the word, the pause before the spark. And though we cannot visit it, we can feel it in certain rocks. In banded iron formations, laid down before oxygen. In serpentinite, formed in ancient ocean crust. In the subtle shift of isotope ratios, hinting at conditions just beginning to lean toward life. These are not answers. They are textures. Textures of a world that waited, and perhaps still waits in other places. Other planets, other moons, silent, still, stone-cold, lava-scarred, hanging in space not because they failed, but because they have not yet begun. Because every living planet starts here, in silence, in stillness, in stone. But the quiet did not last forever. Beneath the surface, the fire had not gone. It had only moved inward, deeper, slower, steadier. And over millions of years, it pulsed through the planet like a heartbeat. A rhythm of heat, repetition, and pressure. One that did not sleep. This was not the fire of chaos. Not the violent flood eruptions of the planet's wild youth. This was deep-time fire, patient, patterned, enduring. Magma chambers that rose and fell in cycles. Mantle plumes that drifted like slow thoughts. Tectonic pressures that built, cracked, and released again and again. And with each cycle, the Earth changed. Not quickly, not dramatically, but over eons. The question, then, is not just what fire did, but what it meant. Because if the early Earth was defined by fire, then fire was the architect of time itself. Not the clock that ticked, but the process that unfolded. Slow convection currents stirred the mantle. Heat gradients shifted. Rocks melted, rose, cooled, and sank again. A great loop, not a line, not a destination, but a process. Could time be shaped by this repetition? Not just measured, but given shape? In the geology of Earth's ancient crust, we find layers of volcanic rock alternating with sediments. Over and over, lava flow, erosion. Lava flow, erosion. Each layer tells a version of the same story. Fire returns, then retreats. Not always in the same place. Not always with the same intensity. But the rhythm is there. It's hypnotic, almost meditative, like a breath. In again. In this repetition, we find the seeds of entropy, the slow, unstoppable tendency for energy to spread, for order to dissolve, for difference to become sameness. And yet, in Earth's early fire, there was still structure, still contrast. The heat had purpose. It moved, transformed, but always it aged. Every eruption was a release, a lessening. Every cooling was a loss of heat, a step toward balance, toward stillness. And so the question arises, can fire remember? Not in words, not in images, but in patterns. Each cycle of melting and cooling changed the chemistry of the crust. Each repetition altered the composition of the mantle slightly. The isotopes we now measure, the ratios of uranium to lead, of neodymium to samarium, are fingerprints of that ancient repetition. They are records of time shaped not by calendars, but by heat. We think of fire as sudden, but this fire was not. This fire was geological, and geological fire does not rage. It waits. There's something comforting about that, something ancient and slow, because in a world without life, without memory, without intention, the earth still moved with a kind of rhythm. It didn't need to know it was doing it. It just did. Heat rose, rocks softened, pressure built, and in time it all began again. This was deep time, not time we can count, but time we can only feel through stone. The kind of time that stretches across eras, that doesn't care about minutes or millennia, that erodes even memory itself. And yet, this deep time of fire created the conditions for life. By cycling heat, it cycled matter. By melting rock, it brought up nutrients. By forming new crust, it shaped oceans. By driving plate tectonics, it sculpted landscapes that would one day host forests, rivers, thought. None of it rushed, and all of it burned. Even now, the fire remains. Beneath your feet, the mantle churns. New islands are born from submarine volcanoes. New crust is formed along mid-ocean ridges. The cycle never stopped. It only slowed. We live on a cooled version of an ever-burning world. And the question lingers, if repetition shaped the planet, does it shape us? Are we echoes of that same rhythm? We breathe in cycles. We sleep and wake. We live and die and return to the soil. Even our thoughts loop. Our histories repeat. Our civilizations rise, fall, and rise again. Not unlike magma surging through the same faults, again and again. Maybe deep time isn't just about geology. Maybe it's about perspective. About learning to see time not as a straight line, but as a spiral. A looping fire that forgets nothing and erases nothing, but folds everything back into itself until the shape becomes familiar again. And maybe that's why we find comfort in campfires, in volcanoes, in the flicker of heat on cold nights, because the fire remembers for us. Not what we did, but that we came from this. And if time itself was born in fire, then so were we. But what then is solid? What does it mean to walk on something and believe it will hold? The crust beneath us feels permanent. Mountains seem fixed. Valleys seem etched. We build our homes on the assumption that the ground will stay where we left it. But what if this confidence is an illusion? What if the very idea of solid ground is something the earth only performs for a while, before returning to its deeper truth? Because beneath every continent, the lava still moves, and beneath every notion of permanence, the planet still breathes. We tend to think of the oceans as fluid and the land as stable. But in geological time, this reverses. Oceans rise and fall with the pulse of water. Continents drift and fracture, melt, and reform. They are not anchored. They are rafts, buoyant fragments of crust floating on an ocean of hot rock. This is not metaphor. It is tectonics. The lithosphere, the outer shell we call land, is broken into plates. These plates rest on the asthenosphere, a hotter, weaker layer of the mantle that flows ever so slowly. The solid surface is not truly still. It glides. It grinds. It subducts and resurfaces. Even the tallest mountains are passengers. Even the oldest rocks are drifting. What we call continents are just the current shape of what cooled first. And that shape will not last. Because underneath the silence of forests and cities, the lava still churns. There were times, many, when Earth's surface was not divided between land and sea, but was instead a unified sea of lava. A planet glowing from its own unrest. No crust thick enough to resist. No structure lasting longer than a cycle of cooling. The Earth as an ocean of magma, ever shifting. And though the crust has thickened since, the ocean has not truly left. It is only hidden. That is perhaps the great illusion. That we live on land. We do not. We live between eruptions. We live on pause. There are places where the illusion thins. Where lava reminds us that it hasn't gone. The volcanic islands of Hawaii. The rift valleys of East Africa. The edges of tectonic plates where new crust forms and old crust melts. These are the cracks in the mask. The places where Earth speaks from its deeper voice. But even the places that seem quiet, the interiors of continents, the plains, the deserts, are not immune. They are simply farther from the heat. Not separate from it. Not safe from it. Only suspended above it. We walk on stone and call it stable. But beneath that stone are currents. Slow, massive, relentless. We speak of earthquakes as disruptions, but they are reminders. Reminders that we are not above the ocean, only within it. That solidity is relative. That the crust is thin. That even now, the Earth moves beneath the floor of our certainties. So what does it mean to live on something so temporary? Maybe it humbles us. Maybe it makes us pay attention to the quiet. Because even now, the lava waits. It is not angry. It is not impatient. It simply is. It is the state the Earth returns to when left alone. And we are the anomaly. Civilization, memory, agriculture, thought. All of it rests on a thin crust that might one day melt again. One day fold back into the heat it came from. And if it does, it will take with it not only our cities but our assumptions. Because the Earth does not need continents. The continents are just this version of the pause. And when the pause ends, the ocean of fire will rise again. Not with rage, but with memory. Because even fire remembers what came before. And when it returns, it does not need to explain itself. It only needs to flow. But flow does not always mean forgetting. We imagine lava as destruction, and rightly so. It buries, it melts, it silences. We picture ancient forests turned to cinder, rivers swallowed, even memory itself erased in the glow of molten rock. And yet, what if lava doesn't simply destroy? What if, in its own elemental way, it remembers? Not with words, not with stories, but with structure. Because even magma holds data. Deep within the minerals that crystallize as lava cools, in their chemistry, in their isotope ratios, in their crystalline forms, are the fingerprints of Earth's past. Ancient temperatures, pressure histories, chemical environments, clues, messages, not spoken but encoded. We call this geochemical memory, and the planet is full of it. Consider the zircon, a tiny crystal, barely visible, yet capable of surviving for billions of years. It forms in molten rock, often during continental collisions or volcanic eruptions. And once formed, it holds on. Even as the rocks around it are crushed, melted, or buried, zircon often remains. Unchanged, unbroken, still speaking. Inside zircon are traces of uranium, which decays slowly into lead. By measuring the ratio between them, scientists can determine a zircon's age with astonishing precision. Some zircons found in the Jack Hills of Western Australia are over 4.3 billion years old. That means they formed just a few 100 million years after the Earth itself. Older than any mountain, older than any ocean, older than life. And inside those crystals are not just ages but memories. Isotopic clues reveal whether liquid water was present when the crystal formed, whether the crust was already cooling, whether granite had begun to differentiate from basalt. These aren't just facts. They are whispers from a world no longer visible. And many of these whispers come from magma, because lava doesn't erase everything it touches. Sometimes, in the chaos of eruption, it captures, suspends, freezes. Think of volcanic glass, obsidian, formed when lava cools too quickly to crystallize. Trapped inside are traces of gases, of tiny crystals, of the chemistry of the melt itself. Each sample a snapshot of the Earth's interior at the moment it surfaced. Even in the violence of eruption, there is pause. Even in the flow, there is structure. Magma is not random. It evolves. As it rises through the crust, it changes, absorbing minerals, releasing gases, separating into layers. And with every phase of this journey, it collects information. Temperature, composition, pressure. Trace elements from rocks it passes through. And when it cools, all of that is locked into stone. In this way, lava becomes a kind of hard drive, a geological archive of thermal and chemical events. Not just of the eruption itself, but of the conditions that led to it. We study these through isotope geochemistry, measuring the ratios of elements like strontium, neodymium, and hafnium, which vary depending on where in the Earth the magma came from. Each ratio tells a story. This one from the deep mantle, that one from recycled crust, another from a place we haven't yet found. Even the gases trapped in lava, carbon dioxide, sulfur dioxide, helium, carry isotope signatures that reveal the age and behavior of Earth's interior. Some helium isotopes, for instance, suggest the presence of untouched reservoirs deep in the mantle, unchanged since the planet's formation. What else waits down there? What unread memories are buried beneath kilometers of crust, still warm, still shifting, still whispering through mineral decay? We may never know, but we know this: magma does not forget, cannot, because everything it touches leaves a trace. The melting crust alters its composition. The pressure of the chamber shapes its path. The speed of the eruption freezes certain forms while distorting others. And all of it, every variable, every subtle change, is written down in the molecular structure of the cooled rock. We only have to learn how to read it. And we are learning. Every time we drill into a volcanic province. Every time we measure zircon. Every time we map a magma chamber hidden beneath the crust by its seismic echo, we are reading deeper into the planet's memory. The kind of memory no species could hold. The kind only fire could write. And it is humbling, because while we erase our memories with time, the Earth preserves hers in stone. Not always visibly, but persistently, because destruction is never complete. Because lava, even when it burns, also crystallizes. Because memory, even when it melts, sometimes cools again into form. And yet, even the oldest forms are not whole. They survive barely, scarred, fragmented, holding only pieces of what they once contained. The cratons, Earth's oldest crustal fragments, are like torn pages scattered across time, the remnants of a book half burned and half buried, still smoldering in silence. Cratons are not just old. They are ancient beyond imagining. Some of them, like the Kopval in South Africa, the Pilbara in Australia, the Canadian Shield, have endured for over 3 billion years. They are the skeletal remains of Earth's first continents, the stable cores that refuse to sink back into the mantle. But they are incomplete, not because of age alone, but because of what they lived through. Imagine a world where the surface was constantly reshaping, where crust collided, sank, folded, melted, rose again. Imagine fire pushing from below and meteorites falling from above. The early Earth was not a calm reader of its own history. It was a restless editor, tearing pages out of its past, scattering them across molten seas. And yet, a few pages held. These are the cratons. Thick, buoyant, chemically distinct. Cratons are made of rock that refuses to yield. Cooler, more rigid, and less dense than the rest of the mantle. And because of this, they float higher. They endure longer. They form the roots of continents. Beneath your feet, if you're lucky, may lie a craton, deep and ancient, stretching hundreds of kilometers down, older than life, older than oxygen, older than oceans. But even they are not untouched. Even they show signs of trauma. Their margins are frayed. Their edges have been stitched together with newer rocks. Their interiors are cut with faults, intrusions, molten scars. What we have today are shadows, outlines of something once more complete. The original cratons may have been larger, broader, woven together in vast landmasses long lost to subduction and time. Some may have been swallowed entirely, pulled beneath the crust and erased. Others may remain, buried so deeply we have not yet found them. Or perhaps, they remain only in chemical memory, in isotope signals hidden in younger rocks, whispers of crust that no longer exists, but once mixed with magma before disappearing forever. Even the surviving cratons are mysterious. Their rocks are metamorphosed, transformed by pressure and heat over billions of years. Their minerals are ancient, but their arrangements are altered, like texts rewritten, overwritten, scorched, and rebound. We read what we can, but much has been lost. Still, the cratons anchor us. They give us a glimpse of the earth before the world we know. A world without trees, without air we could breathe, without animals or even complex cells. And yet these rocks were already ancient. When the first algae appeared in shallow seas, the cratons had already been silent for 1 billion years. What stories did they once contain? What landforms? What climates? What failed beginnings? We do not know. We can only trace their scars. Measure the decay of their isotopes. Study the zircon crystals embedded in their granite. Listen to their seismic profiles as sound waves ripple through their dense, stable hearts. And still, they keep secrets. Like the blackened corners of a burned manuscript, the cratons hint at a larger narrative. One we cannot recover. Not because it is beyond science, but because it is beyond survival. Even the most ancient stone forgets eventually. Even the Earth's most stable structures crumble, given enough time. But still, we honor what remains. We map them. We name them. We study their chemistry like monks preserving fragments of a sacred text. Because each craton is a chapter, even if incomplete, in the book of Earth's beginning. And the presence of these fragments suggests something powerful. That even in the most turbulent beginnings, something can endure, even if changed. Even if incomplete, even if most of it is missing, because sometimes a shadow is enough to know that something once stood in the light. But what if there was never light to begin with? What if what we find, buried deep in the oldest rocks, isn't the memory of life, but the memory of its absence? We often think of fossils as the delicate remains of creatures long gone, the curve of a shell, the press of a fern, the bones of something that once breathed. But before there was life, before biology took hold, there was still fossilization. Only it looked very different. Not the fossilization of bodies, but the fossilization of silence. Mineral forms, crystal growth, pressure-molded voids, echoes of processes, not organisms. These are not remnants of the living, but the traces of a world that had not yet begun to live. What does it mean to fossilize a world like that? To preserve not action, but waiting? To record not change, but potential? In the deep crust, in the oldest sedimentary rocks, we find structures that seem to echo, not with voices but with conditions. Laminated iron formations, layered silica deposits, pillow lavas formed when molten rock met early oceans. These are forms shaped by heat, chemistry, and time, by the planet's body, not yet animated by biology. And still, they tell stories. A ripple frozen in volcanic glass may not be alive, but it tells us there was water. A layer of alternating magnetized minerals may not be a fossil, but it tells us the Earth already had a magnetic field. A band of iron oxide may not be breathing, but it tells us something was reacting, even if not yet living. These are the protofossils of a lifeless world, the shapes that formed when the only forces were gravity, heat, and elemental desire. They do not speak of memory in the way we usually mean it, but they hold continuity, and maybe that, too, is a kind of remembrance. Even the simplest minerals can record time. The alignment of crystals tells us the direction of stress. The shape of cavities tells us how gas moved. The presence of certain isotopes, sulfur 34, carbon 13, oxygen 18, whispers of temperatures, of fluid chemistry, of ancient atmospheres still thick with carbon and uncertainty. These minerals are not alive, but they are not meaningless, because the Earth, even before life, was writing itself down. Not with language, not with DNA, but with structure. And these structures persist. Sometimes we find formations so old, so strange, we hesitate to interpret them. Stromatolite-like domes that might have been formed by microbes or by purely chemical processes. Concentric patterns in chert that resemble cells, but lack their complexity. We call them pseudofossils, not because they pretend, but because they exist at the boundary between biology and geology, between silence and speech, between matter and meaning. And maybe that's the real question. Does it have to be alive to speak? If a rock holds the shape of an environment, the memory of a tide, the residue of a chemical gradient, is that not a kind of fossil? Is that not the Earth remembering itself, even in the absence of witnesses? We often define fossils by the presence of carbon, by cellular detail, by the story of a thing that once moved. But perhaps we need a broader definition, one that includes the marks left by stillness, the textures left by silence, the stories left by a planet still dreaming of breath. Because the Earth was not empty even before life. It was active. It was sculpting. It was becoming. And in that becoming, it left behind impressions not of living beings but of living conditions. So what does it mean to fossilize silence? It means to find a pillow lava and know the ocean was already there. It means to see a banded iron layer and know the chemistry of the sea. It means to touch a crystal vein and hear the cooling breath of magma long vanished. It means the silence is not empty. It is filled with form. It means that even before life, the Earth was already a memory keeper, not through genetics but through geology. And maybe that's why we look, why we study these oldest rocks with such care. Not because they tell us where we come from, but because they tell us how the stage was set. Because long before anything lived, the Earth had already begun to remember. And long before anything could forget, there was stone. And stone, if nothing else, does not lie. But it does repeat. Not in words, not in stories, but in cycles. Quiet revolutions of form. Erosion, eruption, burial. Pressure, uplift, collapse. The Earth turns inward, then outward over and over, not in circles exactly, but in loops where each new layer is a variation of what came before. We often imagine time as a line, past to present to future, moving in one direction. But in the rock record, time feels different. It folds, it spirals, it returns. And each time it returns, it leaves behind a slightly altered trace. A geological echo, layered into the crust like verses in a song older than memory. These loops are not perfect. They are not predictable like clockwork. But they are there, written into the bones of the planet. And they begin with erosion. Mountains rise, but they do not stand forever. Rain falls, winds carve, ice scrapes. The tallest peaks are worn down, grain by grain, their mass carried to the sea. The detritus becomes sediment, a slow accumulation of powdered history, gathering in basins, in deltas, in quiet places. That sediment layers, compacts, hardens, and then the cycle turns. Burial. As more sediment piles on top, the lower layers sink. Pressure rises. Temperature climbs. The rocks transform. Sandstone becomes quartzite. Shale becomes slate. And in some places, as the crust flexes, the whole package is shoved deeper into the realm of heat. Eruption. Maybe not right away. Maybe not for millions of years. But eventually, pressure finds a path. Magma rises. The heat from below ruptures the silence. New rock forms, igneous this time, born from melt. It pushes into older layers, cuts across ancient sediments, reshapes the structure of the past. And then, it too is exposed. The crust uplifts, the surface erodes again, and the loop continues. Erosion, burial, eruption, uplift, collapse, renewal, time written in stone, returning to itself. We see it in unconformities, gaps in the record where rock was once deposited, then eroded, then buried again. The great unconformity, for example, spans over 1 billion years in some places. A missing chapter between ancient basement rock and younger sediment. It's not just an absence. It's a turning of the loop. We see it in metamorphic belts, where sedimentary layers have been twisted and compressed by forces deep underground, only to be raised and revealed at the surface once more. We see it in cyclic sedimentation, rhythmic patterns in rock layers that reflect changing sea levels, orbital shifts, glacial pulses. Even without life, the Earth has rhythms. And these rhythms repeat. Not exactly, not precisely, but with enough similarity that they leave a kind of patterned memory in the rock. A loop is not a failure to change. It is change repeating itself with nuance. It is variation within constraint. And in the deepest rock records, we find this looping time not only in layers but in chemistry. Oxygen isotopes that rise and fall in rhythm with ancient ice ages. Carbon signatures that fluctuate with volcanic outgassing and planetary respiration. Strontium ratios that trace the weathering of continents over deep time. These are not static facts. They are movements, cycles of action and response, erosion and deposition, burial and release. And so we wonder, could the planet be using these loops as a kind of memory system? Not consciously, not with intent, but functionally, a way of preserving the history of its own behavior, not in scripts but in structure, in repeated forms, in echoed chemistry, in the scars of cycles played out again and again. What if each tectonic collision, each mountain-building event, was not just a one-time occurrence, but part of a deeper, looping rhythm? What if time for the Earth is not a race, but a spiral, a slow, circling return, always moving, never still, yet never truly leaving the past behind? Maybe this is why certain landscapes feel ancient, even when their rocks are young. They carry the shape of repetition, the whisper of something the planet has done before and will do again. And maybe we feel that somewhere in our bones. After all, we are products of these same loops. Our continents rose from ancient sediments. Our water cycled through volcanic outgassing. Our air was shaped by the breath of rocks long buried. Even our biology carries the imprint of repetition, DNA that duplicates, adapts, and loops across generations. So perhaps we are part of the loop too. And as we read the rocks, we are not just studying the past. We are watching the rhythm of time itself. Not fixed, not linear, but living. And in every folded mountain, every buried basin, every eroded coastline, we find the same quiet reminder. The Earth does not move forward. It moves through. And as it moves, something else happens. Something quiet. Something irreversible. Something we call entropy. Entropy is not chaos. It's not disorder in the loud, dramatic sense. It's the slow drift of energy from concentration to diffusion, from heat to coolness, from motion to stillness. Not because something went wrong, but because this is how the universe ages. And nowhere is this more visible than in the fire that built the planet. Lava once poured across the Earth in endless rivers. Radiant, molten, unstoppable. It surged up from the mantle with purpose, with pressure, with energy drawn from the deep interior of a still hot planet. But that fire, no matter how fierce, could never last. It always cooled, always settled, always stilled into stone. We walk across its aftermath every day. Cooled basalt plains, silent lava plateaus, ancient igneous shields now covered in soil or forest or sea. What once glowed now grows moss. What once moved now barely remembers how. But memory still lingers in temperature, in density, in the delicate fracture lines of ancient rock. The fire is gone, but its entropy remains. Because every time lava flows, something is lost. Not visibly, not in form, but in usable energy. The heat that once roared from the Earth's heart escapes into the atmosphere, into space, into silence. And once it's gone, it doesn't return. This is the rule. The quiet rule that governs every transformation. Energy spreads. Energy cools. Systems become less ordered, less focused, less alive, unless something feeds them. The Earth, early in its life, was burning with possibility. Radiogenic decay, leftover heat from formation, impacts, friction. All of it kept the interior pulsing, hot enough to reshape continents. Volcanoes erupted not occasionally, but constantly. The mantle churned with urgency. But over billions of years, that urgency eased. The core still burns, yes. The mantle still moves. But slower now, less frequent, less intense. Some regions are geologically quiet, their fire long spent. The basalt that cooled there may never melt again. It simply lies, dark and silent, a record of heat that once was. This is entropy on a planetary scale. We see it in tectonics, where plates that once collided with wild force now drift more subtly, where once active zones go dormant, where uplift gives way to erosion, to flattening, to quiet. We see it in volcanic chains like the Hawaiian Islands, each one older, smaller, more eroded than the one before. The hotspot below still breathes, but the fire it gives off travels farther now, spreads wider, cools faster. Entropy doesn't destroy, it just forgets. Forgets how bright the fire was, how fast the flow once moved, how sharp the boundaries used to be between heat and cold, between solid and melt. And that forgetting becomes the texture of the world. Even the basalt itself, once so fluid, so hot, cools into tight crystalline patterns, hexagonal columns, fine-grained surfaces, a frozen fingerprint of what the lava once contained. And even that structure breaks down, given time, cracks, fractures, weathering. It becomes gravel, then clay, then sediment. Energy, reduced. Form, loosened. And still the Earth goes on, not in defiance of entropy, but in harmony with it. Because life and geology do not resist entropy. They dance with it. They rise briefly in concentrated motion, and then fall back into stillness. The eruption, the uplift, the moment of fire, is always temporary. But in that temporary flash, something beautiful happens. A volcano erupts. Energy leaves the planet, but new land is born. A lava flow cools, entropy rises, but crystals form, complex and precise. Even in loss, the planet creates, not because it intends to, but because creation and entropy are not enemies. They are companions. One opens the door, the other leads us through it. So what happens to energy over eons of lava flow? It fades. It moves outward, cools into memory. And in doing so, it leaves behind the Earth we know. Not a planet of fire, but a planet shaped by fire. A planet where entropy speaks not in destruction, but in stone. In wide basalt fields, in folded mountain roots, in silent faults that once shook continents. The fire may be quiet now, but its voice remains, whispering in cooling rates, speaking in isotope decay, singing softly through the very crust we walk upon. And the deeper we listen, the more we hear it. Not in flame, but in the gentle, patient hush of everything once bright, now cooling. But cooling isn't the end. Cooling is just the beginning of erosion. And erosion, slow, persistent, inevitable, is not just the sculptor of landscapes. It is the eraser of identity. Because nothing on Earth stays as it is. Not for long. Not really. Even the hardest stone, once cooled and formed, begins to wear. Wind scrapes, rain seeps, ice expands, and over time edges soften, patterns fade, names blur. What was once a distinct formation becomes a hill, a plain, a handful of sediment drifting downstream. And so we ask, what does the Earth forget as it erodes? Not just its shape, but itself. Not just its surface, but its story. A mountain may rise through fire, grow tall through collision, stand firm through centuries. but given time, it will crumble. Its peak will weather, its flanks will collapse, its identity as mountain will disappear, replaced by something quieter, more fluid, more easily forgotten. We speak of rocks as stable, but in deep time, even they are temporary. And yet, identity in human terms craves permanence. We want to know what something is and expect it to stay that way. A volcano, a valley, a riverbed. We give names, we draw maps, we build stories around these forms. But the forms are always in motion, always dissolving. In the geological archive, identity is layered. A rock is not just one thing. The sediment, then pressure. Melt, then crystallization. Uplift, then erosion. It is a cascade of becoming, a sequence of losses and gains. And each time it changes, it lets go of something it once was. What if that's what identity really is? Not a fixed shape, but the trail of what has been worn away. Erosion is not destruction. It's transformation. A granite outcrop becomes sand. The sand becomes sandstone. The sandstone becomes buried, metamorphosed, folded into a mountain, then worn down again. The material remains, but the form, the context, the name all change, all erode. We might think of this as forgetting, but maybe it's a different kind of memory, not the kind that holds on, but the kind that lets go. Because holding on too tightly isn't always strength. Sometimes survival means shifting, adapting, becoming something else. The earth does this effortlessly. It does not cling to form. It simply flows from one to the next. But we, watching it, struggle. We look at a cliff and want it to stay a cliff. We mourn when the coast recedes. We fear when a familiar rock face crumbles into the sea. Because we think of change as loss, as the vanishing of meaning. But what if meaning is made in the erosion? What if the most honest identity is the one in motion? What if the self, like the stone, is not carved once and forever, but reshaped, again and again, by the forces that pass through it? Maybe the mountain is no less real when it becomes a valley. Maybe the riverbed still holds purpose when it dries and cracks into dust. Maybe we, too, are meant to wear down in ways we don't yet understand. And still, the materials remain. The atoms don't leave. The minerals persist. Even the grains of sand were once peaks. Even the clay was once a lava flow. Even the dust in the wind was once part of something sharp and bright and whole. We may lose the form, but we never lose the substance. The earth forgets, yes, in shape, in structure, in surface. But it also remembers differently. Not by keeping things the same, but by letting them change without vanishing. Identity, then, is not a monument. It's not what resists the weather. It's what the weather reveals when everything extra has been stripped away. And perhaps that's what the earth teaches best. That who we are is not in what we preserve, but in what we allow to be worn down, layer by layer, until only the most essential shape remains. And even then, even beneath that shape, something deeper moves, something older than rock, quieter than erosion. Because long before landscapes rose and fell, before weather carved valleys or life stirred in oceans, the planet was already following cycles. Even in fire, there was rhythm. We tend to think of climate as a recent idea, as something that begins with air, with water, with clouds. But Earth's climate, in its most fundamental form, began long before there was an atmosphere we could breathe. Before rain, before wind, when the world was still wrapped in magma and skyless heat. Even then, Earth was not still. And where there is motion, there is pattern. The earliest climate cycles were not shaped by seasons, or rainfall, or forests. They were shaped by forces cosmic and internal, the long loops of orbit, the changing breath of the sun, the shifting churn of the planet's molten interior. The fire that coated the earth was not random. Pulsed, convected, cooled in rhythms written not by weather, but by gravity and time. Even now, we see echoes of those first patterns. The earth orbits the sun not in a perfect circle, but in a slow ellipse, one that changes shape every 100,000 years or so. This variation, along with the tilt of Earth's axis and its gentle wobble over time, forms what we call the Milankovitch cycles. These cycles drive ice ages, shift ocean currents, rearrange climate belts. But they began influencing Earth long before glaciers ever formed. Even during the Hadean and Archean eons, when fire ruled the surface, the planet was already drifting through these same gravitational rhythms. The difference was, there were no ice sheets to mark their passing, no trees to track carbon, no air stable enough to record change in snow. So if these ancient climate pulses existed, where are they now? What if they are hidden in the lava? Magma may seem chaotic, but it carries memory. Its chemistry shifts depending on how deep it forms, how quickly it rises, what elements it absorbs. And those changes, if tied to long-term cycles in solar radiation or tectonic pressure, might encode subtle fingerprints of early climate rhythms. For instance, fluctuations in internal convection, the way heat moves through the mantle, could reflect changes in Earth's rotation, in tidal forces from the moon, in how the young planet cooled. These convection currents control where magma rises, how crust forms, when volcanoes erupt. If those flows changed on a cycle, the lava might carry traces of that shift. Some scientists believe early Earth went through vast volcanic pulses, periods of intense outpouring, followed by relative quiet. These pulses might align with mantle overturns, where deep materials rose and reshaped the entire crust. Could these be tied to early orbital patterns? To solar variability? Speculative, yes, but not impossible. Even in basalt, the dense, dark rock of ancient lava flows, we can measure trace elements and isotope ratios that reflect the environment in which they formed. Some show signs of cycling, layers of lava interbedded with thin sediments, each suggesting a different temperature, a different pressure, a different phase. It's like reading the heartbeat of a planet that had not yet cooled. A climate with no rain, no snow, only fire, only the slow shift of sunlight and shadow across a world too hot for either. And yet that rhythm persisted, because climate is not weather. Climate is pattern, and pattern can survive even in chaos. In the absence of air, Earth's early energy balance was set by what it absorbed from the sun and what it released into space. These flows depended on orbital distance, planetary tilt, volcanic gas output, the reflectivity of molten rock. And they fluctuated slowly, subtly, but continuously. Could it be that the very idea of climate, the long breath of the planet, began before life had lungs to feel it? Could it be that the first seasons were not cold and warm, but molten and less molten? Could convection cycles have mirrored orbital cycles, creating hotspots that pulsed in and out of activity like embryonic continents? Maybe. And maybe those patterns are still buried in the oldest igneous provinces, waiting to be read, not as weather reports, not as tree rings or ice cores, but as thermal signatures layered into stone, messages from a time before air, before water, before even the idea of change. The climate beneath the fire was not gentle. It did not care for comfort, but it was not random. It moved with rhythm, with rules, with loops that would one day shape oceans, forests, breath. And even now, beneath our own shifting skies, beneath our modern concerns and cycles, those ancient pulses still echo, in the spin of the planet, the dance of the moon, the quiet stir of heat beneath our feet. Because even when Earth was molten, it was already listening to the sun, and somewhere in the crust, it still remembers how. But memory, even in stone, is selective. Not every version of Earth survives the telling. We often speak of extinction as a loss of life, the end of a species, a vanishing from the tree of evolution. But what if extinction is something deeper? What if it can happen even in a world with no life at all? What if a planet can forget versions of itself, before anything was here to remember? Before cells, before shells, before the faintest breath of biology. Earth changed, not once but many times. The surface shifted, the crust reformed, the skies thickened and thinned. Entire states of being came and went. The planet reshaped its own body, not just geographically but fundamentally. And each time, something was lost. Not organisms, but potential. Not creatures, but conditions. We imagine the early Earth as a continuous path, cooling slowly, then growing life. But that's a simplification. The truth is more fractured, more layered. There were false starts, worlds within worlds now buried, entire versions of Earth that rose, and then were erased. Could these be called extinctions? Maybe not in the way we usually mean. But if a climate disappears, if a crust is subducted, if an ocean evaporates back into sky, isn't that a kind of death? A loss of identity, a forgetting of form. We don't know how many times the Earth has overwritten itself. How many surfaces were built, worn down, and melted before the one we now stand on. How many proto-continents drifted briefly before vanishing. How many mineral combinations came and went, never seen again. Each one a possibility erased. And not by violence necessarily. Sometimes loss came through slow change, a shift in mantle convection, a subtle tilt in orbital path, a rearrangement of the crust that pulled old formations under. The Hadean world may have held oceans, only to lose them. It may have cooled, only to heat again. These were not catastrophes, but transitions. And yet they took entire worlds with them. Extinctions of context. We see hints of these lost versions in geochemical anomalies, zircons that suggest water before there were oceans, isotope ratios that imply crust older than the crust we now have, ghost signals in the deep mantle that may come from recycled rock no longer found on the surface. They are not evidence. Not exactly, but they are suggestions. Echoes of a planet that has already forgotten most of what it once was. What would it mean to name those losses? To call them extinctions, even though no life had yet begun? Maybe it would help us see Earth differently, not as a static object waiting for life to arrive, but as a restless being, already cycling through identities, long before biology joined the story. And maybe it would remind us that extinction is not only about endings. It's about erasures, about the things that are no longer traceable, the landscapes with no remaining outline. The moments of geologic potential that passed, unseen, unlived, undone. A magma ocean that almost solidified, then melted again. A crust that almost held, then cracked and vanished. An atmosphere that nearly formed, then escaped into space. Could these be called prebiotic extinctions? Or would that be giving too much meaning to absence? Maybe. But the deeper we look into the Earth's past, the more we find interruptions. Breaks in the sequence, silences in the layers, voids where something once was, and now is not. The rock record is not continuous. It is full of gaps. And in those gaps, we feel the presence of lost versions of Earth. Not imagined, but real. Not mythical, but unreachable. The planet has died many times. Not in body, but in possibility. And each time it began again, from magma, from pressure, from dust. And so, perhaps extinction is not a line. Perhaps it is a fold. A way the Earth turns itself inside out and begins again. Not because it must, but because that is what it does. That is what becoming requires. Even before life. Even before memory. Even before eyes open to see the world they were born into. The world was already ending. And beginning, over and over again. And through all those beginnings, all those endings, all that folding and refolding of the Earth's surface, one thing remained constant: lava. It surged, it fell, cooled and came again. But what if it wasn't just motion? What if it was language? We do not usually think of magma as something that speaks. It burns, it builds, it destroys. But speech, that's for the living. For minds, for symbols and syntax. And yet, what is language, really? At its root, it is a patterned release of energy, a way of sending a signal, of transmitting thought, of shaping silence with rhythm and intent. So what if, in its own ancient vocabulary, lava has always been speaking? Not to us, not even for us, but for the Earth itself. Because when magma moves, it does not move randomly. Pressurizes, rises, stalls, and erupts in cycles that can span hours or centuries. These are not just flows. They are phrases, expressions of internal change, of tension built and finally let go. Consider the seismic whispers that precede an eruption. Tiny tremors, rhythmic pulses. A volcano may sleep for 1,000 years, But when it wakes, it announces its return in subtle vibrations, like a whisper through stone. The patterns of these quakes, their frequency, their depth, their amplitude speak of magma on the move. To those who can read it, it's a kind of grammar. The spacing between events, the pressure building in the chamber, the echoing pulse as the ground prepares to break. All of it is information, encoded in movement. Even the heat tells a story. Volcanologists track thermal anomalies across vast ranges, mapping where warmth rises faster than usual, where the crust begins to stretch and thin. A swelling caldera, a line of vents, a sudden rise in sulfur dioxide, each one a sentence in a molten language. And this language is not new. It is one of the oldest forms of expression on Earth, not learned, but born with the planet itself. A system of signal and response, pressure and release. What we hear as violence, the Earth may simply know as speech. A conversation not in words, but in heat. What does it say? Perhaps nothing in the way we expect. But perhaps everything we need to know. That the interior is never still. That the boundaries we draw between land and sea, between present and past, are temporary. That the Earth remembers not in silence, but in pulses. Volcanic rhythms, recorded in layers of ash and basalt, are not just eruptions. They are records of time, repeating patterns. Some volcanoes erupt every few hundred years. Some show cycles of thousands. Their spacing is not random, carries memory. Look at the Icelandic lava flows, stacked in thick rhythmic beds, each separated by layers of weathered soil. Look at the flood basalts of the Deccan Traps, which may have pulsed in waves, altering the climate in intervals. What if these were not isolated events? What if they were stanzas in a geologic poem, one still unfolding, and we, standing at the surface, hearing only the aftermath, miss the continuity of it all? Even in subduction zones, where ocean crust dives beneath continents, the language continues. The sinking plate melts, magma forms, volcanoes arc along the edge, like syllables following the line of descent. A hot spot beneath the Pacific writes a trail of islands. A rift in East Africa opens like a mouth. And beneath it all, the mantle hums with unspeakable meaning. To hear it, we need to slow down, to feel the weight of each eruption, to see the pauses between events as not silence, but punctuation. Because maybe lava doesn't speak in urgency, but in eternity. Maybe it's not trying to tell us something in particular. Maybe it's simply expressing what it is to be a planet, to heat, to move, to build and erase, to remember, not with intention, but with pattern. And when we learn to listen, not with ears, but with instruments, with patience, with humility, we begin to understand that the Earth is not mute. It has always spoken. It's just that its first language was molten. Its first poems were eruptions. Its first sentences were flows. And its first alphabet was pressure, written in the silence beneath our feet. But even that language, that ancient molten tongue, hasn't disappeared. It echoes still, not in fire, but in stone. Because no matter how far we move from the lava's glow, no matter how cool and quiet the surface of the Earth becomes, the memory of that fire remains. Hidden in texture, locked in chemistry, carried silently in every rock we touch. The ground may feel solid, it may feel still, but beneath its quiet exterior, it hums with a past forged in heat. Take any stone, a smooth pebble in a stream, a cliff face along a coast, the granite countertop in a quiet kitchen, and trace it backwards. Beneath its form, beneath its erosion, beneath even its layering, there is fire. It may not be obvious, but it is there. Because all rock, at some point in its journey, comes from transformation, and that transformation almost always begins in heat. Even the coolest limestone, formed from shells and seabed sediments, often contains grains that were fused or altered by nearby magma. Even the gentlest clays were shaped by volcanic ash settling into basins long ago. Granite, formed deep in the crust, began as molten intrusions, slow-cooling magma chambers that crystallized over millions of years. And basalt, perhaps the most widespread rock on Earth, is the purest echo of fire. Dark, dense, born from rapidly cooled lava. Found at the mid-ocean ridges, at volcanic plains, on the Moon, even on Mars. It is the sound of the Earth's interior turned outward. But it's not just about origin. It's about resonance. Because these rocks don't just remember fire, they preserve its patterns. They carry in them the cooling rates, the gas content, the chemical signatures of the eruptions and flows they came from. In igneous rocks, we see the frozen choreography of minerals. Feldspar, quartz, mica, each crystallizing in sequence, depending on temperature and pressure. Each a timestamp, each a line in the quiet story of molten transformation. Even in metamorphic rocks, shaped not by surface fire but by internal pressure and heat, the imprint of fire lingers. Schist, gneiss, marble, all of them once something else, now hardened, compressed, shifted by the Earth's heat-driven movements. And in sedimentary rocks, layered by water and wind, fire leaves subtler traces, thin bands of volcanic ash, iron-rich layers from ancient eruptions, pebbles of basalt rounded by rivers and pressed into new stone. The fire isn't gone. It's just blended. Every rock is a memory of something once too hot to hold. And in that memory, there is unity. Because the diversity of stone, its colors, its textures, its strengths and weaknesses, is born from just a few elemental forces: heat, time, and pressure. Whether deep in the crust or on a volcanic plain, these forces shape everything. And they do so in cycles that stretch beyond sight. A lava flow cools into basalt. That basalt weathers, erodes, becomes sediment. The sediment compacts into sandstone. The sandstone is buried, altered, melted, and reborn into granite. And once again, the fire returns. Even the calmest hills hold this loop within them. Even the softest soil sits atop fire's history. And so, when we hold a rock in our hand, we are not just holding matter. We are holding process. We are holding time. We are holding a moment when the earth once burned, and then cooled just long enough to become solid. Maybe that's why certain rocks feel sacred to us. Why we mark graves with stone. Why we build our temples and our homes with it. Why we gather around hearthstones and circle fire pits with pebbles smoothed by heat. We're not just drawn to their durability. We're drawn to what they carry. They are the cooled whispers of Earth's most primal language. And in every step we take across a rocky shore, or every touch of hand to cliffside, we're brushing against that language again. Not gone, only quiet. Because the fire doesn't disappear. It settles. It solidifies. It waits in form. It becomes mountain, boulder, gravel, dust. It becomes the page. And if we learn to read it, not as geologists, not even as scientists, but as listeners, we begin to hear the deeper music in the stone. The hum of origins, the rhythm of cycles, the truth that even in stillness, there was once motion. And that motion still sings. But what if the song is no longer only from the earth? What if, without realizing it, we are becoming part of the melody, not by listening but by leaving traces of our own? Traces not carved by magma, but forged in circuits. Not cooled from lava, but warmed by us. Because even as the natural fire quiets, a new kind of heat has begun. It hums beneath server racks. It pulses through data centers. It radiates from processors, from industrial stacks, from the hidden lungs of our machines. Could we be creating our own layer of lava now? Not with volcanoes, not with molten rock, but with heat drawn from fossil fuels, from reactors, from the relentless energy of modernity. We do not pour rivers of magma across the land, but we do reshape the crust in other ways. Concrete, asphalt, steel, silicon, plastic, glass layered with rare earths, oceans of lithium, mountains carved for copper. And like lava, these materials spread. They layer, they fuse, they cool into permanence. Parking lot is not basalt, but it behaves like it. A server farm is not a volcano, but it generates heat, moves data, churns constantly beneath the surface of daily life. And together, these quiet infrastructures are laying down something strange, a technofossil layer, A planetary archive not of geology, but of design, of technology, of entropy generated by intent. We build cities, then abandon them. We layer microchips with metals that did not exist in nature. We leave behind tools, trash, signals. What will these become in 10,000 years? In a million? In 100 million? Most of what we make will vanish, yes. Steel rusts. Plastics decay eventually. Our data is delicate, our servers vulnerable. But some of it will survive. Not by accident, but because of the very scale of what we've done. Think of landfills, compressed layers of material already fossilizing. Think of buildings buried in rising seas. Think of satellites that will fall and crash and embed into rock. Some future geologist, if there ever is one, might dig down and find a perfectly preserved circuit board. A seam of aluminum where no aluminum should be. A vein of glass laced with processor elements. They may not know what it meant, but they'll know it was intentional. Because nature does not make patterns like that. Nature does not shape silicon into grids. Nature does not align magnets into storage drives. Nature does not build refrigeration into metal boxes filled with blinking lights. We do. And in doing so, we are leaving behind a kind of synthetic geology, not rock but artifact. Not sediment but signal. We call them technofossils because they are evidence of technology, long after the culture that built them has gone. And even now, before we disappear, we are already producing them faster than we can count. Microplastics in ocean sediment. Radioactive isotopes from nuclear testing, embedded in glacial ice. Carbon-rich layers in soil from industrial combustion. These are markers. They are the stone handwriting of our age. And perhaps, just perhaps, they will remain long enough to be read. The Anthropocene, some call it. The age of humans. But it might just as well be the age of accidental geology, where everything we've built begins to settle into stone. And the irony is this: we've become the fire. We've become the force that reshapes the earth. Not by tectonics, but by scale. Not by magma, but by manufacturing. Not by heat from within, but by heat released without wisdom. And so, we ask again, is this our layer of lava? Are we laying down our own igneous record, built not from mineral melt, but from innovation and discard? Will our cities one day become buried plateaus, mistaken for strange volcanic intrusions? Will our technology, compressed and altered by time, become the obsidian of a future age? Or will it dissolve? Will it vanish, like the cratons before it, leaving only scattered anomalies, fragments that confuse more than they clarify? Maybe, maybe not. But the pattern is familiar. We have seen how lava reshapes, reclaims, erases, and still leaves a memory behind. We have seen how even silence fossilizes. And now we see that we are part of it. Not separate, not observers. We are the heat now. And if we vanish, as all things do, the earth will keep what it chooses. Not the names, not the language, but the material, the layer, the change. That is what stone remembers. And one day, long after the servers go dark, long after the steel bends, long after our glass cities fall to quiet, the planet may still hold the imprint of this moment. Our moment, still warm in the rock. That's where we leave our mark. Not in monuments or maps, but in layers, in dust, and in the strange, invisible precision of isotopes. Because when all else disappears, the cities, the machines, the languages, what remains are atoms. Atoms and the way they decay. Atoms and the stories they never meant to tell. In the quiet world of geology, dust is not just a byproduct. It is not waste. It is record. Tiny grains, often smaller than a speck of sand, carry within them the most intimate measurements of time. Not because they remember, but because they change in predictable ways. Slow, unstoppable, eternal. This is how Earth remembers what we cannot. Through decay, through energy release, through the slow ticking of elemental clocks. We begin with uranium. Locked within certain minerals, especially zircon, uranium atoms are unstable, destined to transform. Over time, their nuclei break down one particle at a time and become lead. This process takes billions of years, but it happens at a steady pace. A rhythm so reliable it allows us to look back further than memory ever could. We call this radiometric dating. But it's more than a method. It is a form of deep listening. A way of hearing the age of a rock not through its shape or feel, but through the ratio of one isotope to another. Uranium-238 to lead-206. Uranium-235 to lead-207. Each pair tells a story. Each ratio is a whisper of time past. Each grain is a clock buried in silence. And this clock does not care if life is watching. Ticks whether we are here or not. It ticks in the oldest crust, in meteorites from before Earth existed, in volcanic ash that cooled in seconds yet holds eons. Even helium plays its part. In a process known as helium diffusion dating, scientists measure how quickly helium atoms, produced by radioactive decay, escape from a mineral. This tells us not just when the rock formed, but how it cooled, how it changed, how its internal structure slowed the passage of time. All of it happens in dust, not towering cliffs, not sprawling formations, but in tiny, hidden places, the scale of thought reduced to a speck. Crystal, a lattice of atoms reshaped over ages. It is in these particles that deep time archives itself. The Earth doesn't write in sentences. It writes in ratios, in particles decayed, in energy released, in what has turned from one thing into another, slowly, predictably, irreversibly. These isotopic systems, uranium lead, rubidium strontium, potassium argon, are the Earth's hardwired memory. They are not opinions. They do not fade with culture. They cannot be rewritten. They simply are. And yet, they are also delicate, because these memory chips of deep time are easily disturbed. A rock reheated can reset the clock. A mineral cracked by pressure may release helium prematurely. Water can wash through a layer and scatter the isotopes like scattered syllables in a broken text. And so, when we find a grain that is intact, undisturbed, sealed, we treat it like treasure. Because it is. It is not just a crystal. It is a witness to an eruption, to a crust forming, to a planet cooling from fire, to a world becoming what it never was before. The oldest minerals we've found, ancient zircons in the Jack Hills of Australia, are over 4.3 billion years old. They are not big. They are not beautiful. But they are perfect. Perfect in their clarity. Perfect in their resilience. Perfect in what they quietly tell us. That Earth had water perhaps earlier than we thought. That crust had formed. That conditions were beginning to allow memory to take root. Not just physically but chemically. And as we analyze these grains, with lasers, with mass spectrometers, with the most sensitive instruments we've ever built, we realize that dust is not the absence of structure. Dust is structure reduced to essence. And essence is what survives. So maybe the future won't remember our buildings. Maybe it won't remember our words. But perhaps it will find a layer, a crystal, a tiny grain of something made during our age, and it will measure it. And that measurement will whisper we were here, that we lived, that we heated the world, that we left behind atoms out of balance, and time made them speak. Because all across the Earth, the memory of fire still lives in stone. And inside that stone, the math of memory unfolds. Not in poetry, but in ratios, in transformation, and in the patient certainty of dust becoming time. We begin to understand that the Earth never truly loses anything. It only changes its form. And in that change, in that slow shift of one state to another, there is something deeply familiar, not just geologically, but existentially. What if melting isn't loss, but transformation? We think of it as an ending, the collapse of structure, the softening of form. Ice becomes water. Rock becomes lava. Memory becomes heat. But what if, in these moments of dissolution, something new is allowed to emerge? Something that couldn't exist without the letting go. In geology, melt is not failure. It is potential. It is the reawakening of motion. A mountain is stable, but it cannot flow. A rock is strong, but it cannot adapt. Only when it melts can it move, rise, shift, become something else. This is what lava teaches. That structure is not sacred. that even the most ancient form must, at some point, give way, that beneath every solid shape is the memory of fluidity, waiting to return. And perhaps that's not just the story of the Earth. Perhaps that is our story, too. Because we, like rock, form identities. We cool into names, habits, shapes of thought. We crystallize into patterns we call ourselves. But those patterns, however familiar, are not fixed. They melt. In grief. In love. In change we didn't choose. In time we didn't expect. And when they melt, we often mourn. We think something has been lost. But maybe, like lava, we're simply being given another chance to become. The Earth has always known this. It melts its crust not to erase it, but to reshape it. Old continents sink, melt, and rise again as new land. Volcanoes destroy and rebuild in the same breath. Metamorphic rock begins as sediment, becomes stone, is melted into magma, and rises again as igneous. It is all part of the same cycle, the same expression spoken in different tongues. And none of it is wasted. Even in the hottest fire, the atoms remain. Even in the deepest subduction, the essence is preserved. It's just that the form has changed. Maybe that's what lava really is. Not destruction, but translation. The Earth expressing itself in motion instead of structure. A reminder that becoming requires surrender. That we cannot always stay in the shapes we love. If we want to grow. It's uncomfortable, this thought. Because melting feels like undoing. Feels like chaos. Like collapse. But look at how magma rises. Look at how it glows. A body of minerals returning to their most honest state. Not hardened. Not fixed. But free. Elemental. Ready. And in that readiness there is hope. Because nothing new is born without heat. Without pressure. Without the courage to let go of the familiar and step, even just for a moment, into fluidity. We are all molten sometimes. We are all undone. All melted by moments we didn't expect. A loss, a turning point, a shift so vast it dissolves who we thought we were. But in that melt we are not erased. We are invited to reform, to recrystallize, to emerge with new minerals, new arrangements, new meaning. Just as granite is born from melt rich in light elements. Just as basalt carries the signature of a deep, primitive source. Lava carries memory, yes, but it also carries possibility. And so do we. We are not static. We are not set. We are beings of geology, yes, but also of philosophy. Our minds, like our minerals, are shaped by time, by heat, by erosion, and by melt. The Earth has never judged itself for changing form. It erupts when it needs to, cools when it can, and it always begins again. So when we find ourselves undone, when identity slips, when meaning softens, when all the old definitions begin to blur, perhaps that too is lava. Perhaps we are simply returning to a state where we can become something else. Not lesser, not lost, but unformed, and waiting to cool, waiting to take shape, waiting to remember that melting is not the end. It is the moment just before becoming. And yet, in every becoming, something is left behind. Not discarded, not rejected, just released, forgotten not by cruelty, but by necessity. Because even the Earth, in all its patient turning, cannot hold onto everything it once was. And so we ask, softly, speculatively, does the Earth grieve its molten youth? Not in the way we understand grief, not with sorrow or memory or longing, but perhaps in texture. In silence, in the fading traces of what it used to be, because this world, stable as it may seem, was once a very different place. Once it flowed. Once it glowed. Once it knew only heat and light and the endless churn of molten change. There were no forests, no clouds, no shadows, no softness, no slowness, only a planet wrapped in flame, writing itself into shape. That fire is gone now, or at least buried deep, muffled beneath oceans and crust and time. But echoes remain. We find them in basalt flows, in iron-rich rocks, in ancient zircons that remember a sky too hot for breath. We see them in the shape of plate boundaries, in mantle plumes, in volcanoes still pulsing with memory. And when we look at these remnants, it's hard not to feel something, almost emotional, not for ourselves, but for the planet, for what it once was, and for what it had to give up in order to become what it is. This is planetary grief, not the mourning of loss, but the quiet weight of transformation, the long, slow surrender of identity as the price of growth. Because to become a world of life, the Earth had to forget what it was as a world of fire. It had to cool. It had to crust. It had to let stillness interrupt the dance. And in doing so, it let go of something wild, something brilliant, something that never truly returns. Maybe that's why volcanic eruptions feel so ancient, because they are not just geologic events but memories. The Earth momentarily remembering what it once felt like to be whole fire, and then again forgetting. That forgetting is everywhere. It lives in the way rock breaks down, in how tectonic cycles bury what they once revealed, in the layers we can't find, the lost crusts, the sunken continents, the ancient climates erased by time. There are pages missing from the Earth story. Whole volumes, in fact. But instead of silence, we find absence, and absence, too, has shape. It is the shape of something once real, now gone. The ghost of an ocean, the trace of a mountain, the shadow of a climate that never made it into sediment. And in those gaps, we feel it. The ache of impermanence. The deep, slow sigh of a planet that has changed too many times to count, and will keep changing. It's tempting to imagine the Earth as indifferent, a machine of physics and chemistry, grinding endlessly forward. But when we sit with its cycles, when we lean into its layers, something else begins to emerge. Not personality, but presence. A kind of emotional gravity that pulls us toward reflection. Because grief is not always loud. Sometimes it is still. Sometimes it is made of stone. And perhaps the Earth, in its vast, wordless way, carries a kind of grief for all its former selves. Not regret, but recognition. The way a river, having carved its canyon, still holds the memory of the path it took to get there. The way cooled magma holds the memory of movement in its frozen waves. The way we, too, carry versions of ourselves long gone. Not clearly, not entirely, but faintly. In dreams, in gestures, in the quiet moments when we feel the weight of time and cannot explain why. What the Earth once was, is no longer here, and yet it is everywhere. In the foundation beneath our homes. In the stones that build our walls. In the elements that course through our blood, iron from the core, calcium from ancient seas, carbon forged in stars. We are made of this planet's memory, and maybe of its forgetting too, because without forgetting, there is no room for the next form. Without letting go, there is no space for life to take root. The fire had to recede. The storms had to settle. The molten silence had to give way to water and air and the fragile logic of cells. Maybe the Earth does not grieve the way we do. But maybe grief is not only sadness. Maybe it is the quiet acknowledgement that something beautiful once existed, and now, something else must grow in its place. And that, too, is a kind of love. Not one that clings, but one that transforms. But even in transformation, not everything disappears. Some things only retreat, not vanished, only quieter, because beneath our feet, beneath the crust, the cities, the mountains, lava still sleeps. It hasn't left. It hasn't ended. Simply waits. Still molten. Still shifting. Still pulsing with the memory of a world once fully aflame. The fire of Earth's youth is not a relic. It is a presence, tucked beneath the shell we now call solid ground. The mantle, that vast, slow-moving sea of rock, still flows, still breathes. Its heat rises in places, finds cracks, swells chambers, fills the lungs of dormant volcanoes. It is not gone. It is just not awake. But what does it mean to say that something sleeps when it is made of rock and pressure and time? Maybe it means this, that fire, like memory, is not always visible but always near. We walk on a thin crust, just a few dozen kilometers, sometimes less. Beneath that, the Earth is still alive with heat, still churning, still making decisions on scales we cannot feel. at hotspots like Hawaii, at rifts like the Mid-Atlantic Ridge, at subduction zones where crust dives back into the mantle, the fire speaks. Slowly, occasionally, but with purpose. Most of the time, though, it stays silent, like breath held, like thought not yet spoken. This sleeping lava is not benign, but it is not cruel either. It is simply waiting for the right moment to return, not out of vengeance, not out of rage, but out of rhythm. Because the Earth is a system that reuses everything. Old crust is pulled down, old minerals melt, old rocks rise in new forms, and the cycle continues, endlessly, patiently. It's humbling to think that the ground beneath us is temporary, that continents are passengers, that beneath our mapped and named world, there is still a landscape we cannot control, only anticipate. But maybe it's also comforting, because the fire beneath us is familiar. It made us. It shaped the land we live on. It formed the air we breathe, the soil we farm, the metals we mine, the minerals in our bones. And so, even as it rests, it holds us. The lava beneath our feet is the Earth's first language, its first voice, its oldest memory. And though it sleeps, it does not forget. It remembers in silence, in pressure, in warmth rising slowly through the crust. It reminds us, too, that the past is never truly past. It's easy to believe that because we no longer live in a molten world, that world is over. But deep time does not work in absolutes. It works in layers, in returns, in slow awakenings. The same mantle that fed the ancient lava oceans still breathes beneath us. The same heat that built the early crust still fuels volcanoes today. The same forces that shaped the Fire Age Earth are still shaping us, just more quietly. We are not above them. We are not after them. We are within them. We are the surface of something older, deeper, more alive than we can fully comprehend. And every so often, it stirs. A rumble beneath the city, a fissure opening in a distant field, a red glow at the edge of the sea, a reminder that beneath the calm of forests and highways, the Earth still carries its molten heart, still dreaming, still building, still waiting, not to destroy, but to renew, because sleep too is part of becoming, and sometimes all that is waiting to rise is already there, right beneath us, still dreaming, still waiting. But dreams too have their limits, and even the deepest fires eventually begin to slow, because no matter how alive the Earth feels, how constant its motion, how enduring its inner heat may seem, something beneath it all is changing. The planet is cooling, slowly, quietly, but undeniably, and we begin to wonder, is the Earth itself winding down? We imagine this world as endless, as dynamic, as invincible, as eternal in its geologic rhythms. But energy once spent is not infinite, and over billions of years, the Earth has radiated away much of what it began with. The violent birth, the molten youth, the radioactive decay that powered continents and volcanism and convection. It's all running out. Not this year, not this age, but in deep time, the Earth's inner engine is beginning to quiet. We are living in the long sleep of fire, not the extinguishing of it, but the soft slowing, the cosmic exhale after a long and luminous breath. Consider this: when Earth first formed, it glowed. The entire surface was molten. The core was chaos. The mantle roiled like an uncovered sea, and heat poured into space at an unimaginable rate. Now the heat still flows, but slower. The crust has thickened. The mantle's movements have become more subdued. Some regions of the planet are geologically quiet, their tectonics stalled, their volcanoes long gone. This is the planet aging in real time, and though we often focus on its cycles, the eruptions, the earthquakes, the floods, we rarely speak of its stillness, of the places where the fire has gone quiet, of the cooling deep beneath our feet, because fire, like everything else in the universe, is subject to entropy. It spreads. It loses focus. It softens into balance. Even the radioactive elements, uranium, thorium, potassium-40, that fuel the planet's internal heat, decay at steady rates. As they disappear, the Earth's ability to renew its warmth declines. And so we ask, what happens when the fire sleeps too long? Not next year, not in our lifetimes, but millions, billions of years from now. Will tectonics cease? Will the mantle harden into stillness? Will Earth become like the moon, a geologic shell, pocked by time, but silent beneath? It's not just possible, it's expected. Our planet is in its middle age, dynamic, yes, but not as hot, not as active, not as loud as it once was. The continents have stabilized. The crust is thicker. The volcanic activity globally has declined over time. This is not failure. This is evolution, because even planets must rest. And perhaps what we call death, in stars, in systems, in planets, is simply a change in state, a passing into a slower form of being. Earth, once a flame, may one day become an ember, still warm inside, still marked by memory, but no longer remaking itself, a lullaby in stone, a body wrapped in its own silence. And yet, there's something beautiful about that, because the long sleep of fire is not a tragedy. It is the consequence of creation. Everything that has lived, every tree, every animal, every thought, has only been possible because the earth has cooled enough to allow it, because the fire stepped back, because the chaos became structure, because heat became home. And now, as that heat softens even further, we may be witnessing the planet's slow retreat, not into death, but into stillness. A cosmic lullaby, a world at rest. The stars, too, will dim. The galaxies will drift. The universe, at its own scale, will cool, expanding into silence. Earth is no different. It began in light. It moved through fire. It softened into soil. And it may one day sleep fully, a cooled relic of a life-bearing age. But until then, we listen to the deep heat still rising, to the quiet rumble of distant plates, to the sigh of magma moving slowly beneath old volcanoes, because the fire is not gone. Not yet. It only dreams deeper now. And as long as it dreams, the planet remembers what it was, and what it made possible. But now, as we stand at the end of this journey, at the cooling edge of a world once made entirely of flame, one question returns, quietly, as if it had never left. What if the fire was watching us all along? Sounds like myth, poetic thought, the kind of question one only whispers late at night, when the lights are low and the world feels still enough to listen. But is it really so strange? We've walked through the geology, through the molten past, through the isotopes and the zircons and the ash, through the rise and rest of lava, the cycles of crust and mantle, the dreams of sleeping magma. And through it all, one force has been constant. Fire, not as destruction, not as punishment, but as presence. The first presence. Before oceans, before continents, before breath and leaf and language, there was heat. And that heat, unthinking as it may seem, set everything in motion. So we ask again, what if the fire in some elemental way saw us coming? Not with eyes, not with foresight, but with pattern. What if it built the world not for us, but in a way that would allow us to emerge? We are, after all, made of this planet. Our blood carries iron, drawn from the same core that still spins below us. Our bones are built from calcium and phosphorus, once pulled from erupting stone, dissolved in ocean, returned to land. Our breath moves through an atmosphere shaped by volcanic gas, cooled by ancient lava, stabilized by plate tectonics. We are not separate from the fire. We are its descendants. So is it so strange to wonder if it left us clues? Not messages, not designs, but shaping forces. Heat that cracked the crust to create islands. Convection that drove the rise of continents. Cycles that formed oceans. Magnetic fields that shielded our fragile molecules from solar wind. Pressure that forged diamonds and minerals and conditions that would, one day, allow memory to awaken. Perhaps the fire didn't watch us, but perhaps it framed us, carved the edges, drew the outlines, lit the slow, slow path that led from silence to awareness. And now here we are, thinking, walking, looking at ancient rock and asking where we came from, why the world moves as it does, and what part of it, if any, still holds us. The molten planet of our origin is gone, but its shape is not, its rhythm is not, its heat, even cooled, still pulses in every plate boundary and hot spring and volcano. And more than that, its memory is in us, because memory is not only what we find in stone. It is what we carry forward, what we repeat, what we feel, when we walk through fields of black basalt or stand at the edge of a caldera and feel the earth breathe below. It is what draws us to fire, again and again, not just for warmth, but for meaning, for connection. We gather around it. We dream beside it. We stare into it as though it might speak. And maybe it does, not with language, but with the same shaping energy that made the world. What if the fire still burns through us? What if our curiosity, our instinct to build, to imagine, to rework and reshape, is not separate from Earth's fire, but an extension of it? What if we are fire that learned to walk, to wonder, to name its own heat? And if so, what do we do with that inheritance? Do we burn blindly, or do we remember how to carry the flame carefully, not to erase but to illuminate? Because we, too, are shaping the world now. We build our own crusts, cities, roads, machines. We dig into the mantle. We release stored energy faster than the planet can balance. We have become another cycle, another force. But unlike magma, we choose. We can pause. We can reflect. And maybe that is the gift the fire gave us, not control but consciousness. The ability to see ourselves as part of something larger, older, more alive than we ever imagined. So as the earth cools, as the fire sleeps deeper, as the rhythms slow, we, the children of molten stone, can still listen, still speak, still remember, because even now, after everything, we carry the fire forward. Thank you for walking this journey. If this story helped you drift into rest, into wonder, into a quieter space of the mind, consider sharing it, subscribing, or simply sending it to someone who dreams of ancient things. Here at the planet's memory, nothing is rushed, nothing is loud, and everything we explore is lit by the softest possible glow. A fire older than words, still burning, somewhere deep inside. Sleep well,